the Ruby developers left in-house. So we decided we needed to have a much better tool for doing DNS delegation testing and our measurements. So we decided to create a new reference tool, which was supposed to be much better than the previous ones. So what we decided to do, we needed to base it on both DNSSEC and ZoneCheck and create the joint requirements and specifications for the tool. And for the first version, we wanted to completely replace both DNSSEC and ZoneCheck, so we wrote everything that the current tools already did and just wrote us as requirements for the new tool. And we also decided on a new name, which was the hardest part. I presented this 18 months ago, I think, at the DNS OARC in Warsaw. And we just came up with a new name then, and we started to work on it. But we have come a long way since then. So what we wanted to have for version 1.0 is all the test cases that DNSSEC and ZoneCheck already did, and all functionality, which meant web interface and everything. We also wanted to have a modular code, so any developer at AFNIC or DNSSEC could write code independently from each other. And we also wanted the tool to be faster and have a lower impact on the network, querying less than the previous tools. So we ended up with a long list of requirements. I think we had close to 80 or 90 requirements when we have collected all of the test cases that we wanted to implement. So if you look at the current requirements we have today, there are a lot of them missing. For example, RO8, because when we collected all these requirements, we threw away a lot of them. And there are things like duplicates and things that we don't really want to test anymore. There are lots of email things that we don't want to have in the DNS testing tool. And we also divided those requirements into different areas. We have 7 or 8 areas today where we can get into more detail about the specific tests later. So to keep track on all the requirements and the implemented test cases, I created a small script that can generate a table from the markdown documents that we have on the requirements. And this makes sure that we don't miss anything that we wanted to implement. So it takes all the requirements, see that there are actual implementations of those requirements. It's also good, gives you a good overview of what is in there as well. This is an example of one of the test cases. So at the top you have the identifier and an extremely short description of what the test actually do. You have the objective where you have references to what you are testing. And in this case it's UDP connectivity, and we try to find the RFC where it actually is stated how a connection in DNS occurs. For inputs, it's most often the domain name that you want to test. And then you have the order description of the steps taken to execute the test. So all the test cases are written in isolation. So you can, in this tool, just perform one test, and that should be a complete coverage of this document. So if you look here, you have a reference to method 4 and method 5, which is sort of macros that we use throughout the documents. And those are things that you need to do in almost all of the test cases. So this is, for example, how to obtain the IP addresses for all the name servers listed in the parent and the child. So the objective of this test is to make sure that all the IP addresses can answer over UDP. But then you also have the special procedural requirements, because when you run the test and don't have IPv6 available, you might want to turn that off. So this little text describes what will happen when you are not allowed to query an IPv6 name server, because that functionality is implemented in the framework. So from the test case perspective, what will happen is that you don't get a response. So you need to know about the user wish to disable one of the protocols. Right, so the actual implementation then, it's completely written in Perl. We have 4 different major components. We have the engine, which is all of the test cases, and the test framework. We have the CLI, which is command line interfaces, which is a wrapper around the engine. We have a backend, which is supporting the GUI, which is the web interface. So the ZoneMaster engine is a Perl library in the ZoneMaster namespace, and that implements all the functionality for testing. That means the complete test framework for actually allowing a test to happen. And it also includes all the test cases. And this is also the place where you put, if you want to write your own test case, you put this in the engine code as well. Also functionality for logging the results. It also implements its own resolver, and that is based on net LDNS, which is our own Perl wrapper around LDNS. So we decided to use another library than net DNS this time, because net DNS seems to nowadays be more aimed at developers wanting to use DNS in their code rather than being a DNS debugging library, which we really want, because we have to have lower access to what's happening in DNS. We have the ZoneMaster CLI, takes its input from the user, it executes the test, it publishes a log, and you can publish the log as text, raw text, or JSON. So it looks simple. ZoneMaster backend is in the JSON RPC interface to the engine. So it's mainly used by the GUI to execute tests and give back the results to the user, but it can also be used by any other application that wants to have some sort of batch interface for doing testing. There are also alternative ways of doing it, which I will show. The GUI is also quite simple. It runs the test for the user and presents the result. And you can see it at zonemaster.net, and it looks like this. So you have the domain name that you want to test, and then you get the result, and you can click on the different buttons to see what has actually been tested. You can also do a pre-delegated test. A pre-delegated test is where you don't have the correct delegation set up yet, but it will be in the future. So you put in the future name service and DNS key material in there and run the test. So from the ZoneMaster perspective, is that this data is being fake result coming from the parent rather than coming from the parent in the live DNS. So releases are being done independently by the 4 different modules. So you have ZoneMaster engine being released independently from all the other modules, but we have also the ZoneMaster distribution releases, which is bundling all the 4 components together. So we have the release from December, which is the version 1.0 release. And I expected to have a release on this Friday before coming here, but we failed this. So next release is going to happen next week, I hope. But everything, all the Perl modules for the engine and the CLI is published as CPAN. So if you follow the instruction details anywhere, you will always have the latest releases for those components anyway. So installation is simple as this. We have a lot of dependencies, of course. It's Perl. So this is for your Ubuntu or Debian system. It's quite simple. And then you just do the CPAN installation for the ZoneMaster software itself. And some extra modules for the CLI, and then you do the same for the CLI. So, and then you have a complete ZoneMaster installation. So how do you run the test then? It's just input your domain name, and you have a result coming. The default log level is notice from the CLI. So any log message below that, it will not be shown. So this log is being translated to Swedish and French if you also need that. But you can also do a lot of other stuff. So these are all the command line options for running. I will tell you shortly about some of the features. In the CLI, you can also do pre-delegation tests. You can also record everything you do as a DNS dump that you can play back later. So you can share your strange domain with us if you want to. You can record it and send us the dump, and we can actually see what's happening in our code if there is something very strange in there. You can also replay a recorded dump. If you change the policy or configuration, you can see what happens when you do that and see if you get any new results. You can run the CLI and stop execution at a specific log level. So if you see an error, you stop immediately and notify somebody. You can use different policies for evaluating the results, because we know that the DNS community is not in agreement on what is the severity of any DNS error you might encounter. So the log levels, debug levels 1 to 3 will give you enormous amounts of log, for example, the raw DNS packets themselves. And you can have anything up to critical. Critical means that this domain is probably not working at all. Error is things that we consider serious enough to be, that you really should be fixing it. And these log levels for each single log output is configured by a policy. And the policy looks like this. This is just a short section of it. And there you can go and change anything that you feel that this should be an error, this should be only a warning or whatever. And each of those things does not match exactly a test case, because each test case can generate many different log entries. So the log entries are named independently from each test case. But there is a mapping between, so you can find the test case if you find anything strange. So you have the human readable log. You can also have the log in the raw output format, where you have these tags directly with its metadata. For example, the name server, IP address, or whatever. You can also have it as JSON output, which is perfect for storage. I will give you a short overview of how you can use it. So the anatomy of log entry internally in SoundMaster is that you have a tag, the test case tag, which is globally unique. You have the timestamp from the test started, when did this happen. Module is the logical test module, and level is these log levels. Then you have the arguments, NS address, and so on. We didn't give this much thought when we wrote the SoundMaster software, but now when we're doing an analysis of the results, we must actually clean up the test cases now, how these names and IP addresses ends up in the args fields here. It's extremely simple to write your own applications using SoundMaster. This is much longer than it needs to be, because it's 2 different examples. To execute the test, you only have to type test zone and the name of the zone, and then you can get the logs out of it in different ways. They're also very easy to use SoundMaster for doing other lookups. For example, look up all the name servers for a zone. So there are different examples of applications that you can use. For example, in the CLI module in the script sector, you have the SoundMaster info program, which gives you a very nice overview of the configuration of a domain, with all the glue name servers listed from the parent and the child separately, all the DNS key, the details from the SOA record, and things like that. So it's very nicely script to have a complete overview of a zone. I wrote my own little tool called SoMaster Collector, which is a batch script for doing mass collection of test results. It's multi-threaded, so you can test a lot of domains in a small time frame. You can store the test results in the file system or in the MongoDB database. And this gives you a very easy way to actually analyze the results. There are many examples I've listed in my code here, if you want to test it. So to start a mass collection of lots of domains, just start collecting and store it in the Mongo database. So to start doing queries to the Mongo database, you can do aggregate searches. The example from above is a query for a specific test tag in the results. For example, is a recursor, give me all the domain names that has open recursors, is this query. So it will give you a complete list of all the domains that you have in your Mongo database with the open recursors. You can do a number of different queries like that. You can also aggregate a specific name server. You can query for the error level and match this with group this by name servers. And this is the problem with the ARCs again. When you are collecting groups of domain name servers, you always trust the ARCs to be the address or name or NS or server or whatever. And it's really not coherent in our logging how it works. So that's what we're working on improving on, so that you can do analysis of a massive amount of domains and find common errors. Because one of my tasks at .se is to have a clean SE zone where we improve or lower the number of errors in there. So we are working on fixing all the imperfection from the logs to make this even easier. We are going to implement new test requirements. We have a few that we want to implement, and if you have things in there, please issue a GitHub issue to us and let us know what you need. And these are examples from the survey we had a few months ago. So this was the most popular things that we needed to have. IANA test profile is something that we talked about, because when you're doing a delegation for the root, you have this test specified by IANA that you need to pass before having your delegation in there. So we want to have IANA test profile so that you can run the same test as IANA does before they are doing their delegation. And also HTML export of the results seem popular. So let us know what you need, and we can probably fix it for you. We have some further work with the test specifications within Center, which is the European organization for CCTLDs. We have started up a task force, the TRTF, Test Requirements Task Force, which will work on our test specifications, and the goal is to have a published RFC with the test specifications. So the code is there, it's stable, it should work. We still find a few bugs now and then, but overall all the test cases that we have implemented are stable. So thank you. Any questions?
Hi, I'm Sebastian Castro in Cervez. We're active users of DNSSEC, and we use it like in mass. We scan the whole DNSSEC zone using that. Do you see some master as a kind of drop-in replacement, or requires more a longer path of migration?
There has been some talk about translating DNSSEC messages to look like some master messages. So that's the kind of the reverse migration plan. But,
Okay.
we haven't talked about having some master logs look like DNS check logs.
Okay. The other question is, why is the reason you use your own resolver?
Which resolver do you think we should use instead?
Uh,
I mean, we need to have access to all the errors in the DNS layer, so
Okay,
you
the
kind of
low
need
level
access to
stuff.
all this information.
And on a follow-up, so when you use threads on your mask collector, do you use one resolver across all the threads, or each thread uses their own
Oh,
resolver?
it's isolated, so it's one per thread.
Okay. Cool. Thank you.
Hi, this is Anand from the RIPE NCC. So like Sebastian, we're also active and heavy users of DNSSEC. We actually use it for the pre-delegation checks for the reverse DNS objects in the RIPE database. We really like DNSSEC. I also like the direction this is going in, but one of the questions I had was in DNSSEC, there's a feature called filters. And we specifically make use of it because we have one unusual case where users can request delegation, secondary with one of our name servers, but the name server won't be provisioned while the pre-delegation checks are running. So we use the filter to, let's say, exclude this particular server from checks. This is something we would need in Zone Master. Now, by the looks of it, I think it's doable because you mentioned something called the IANA test profile. So we could, for example, have a similar RIPE NCC test profile with its own requirements.
With its own configuration and policy.
And the other thing was about doing mass background checks. So we also use this feature, we just dump all our domains into the MySQL database every month for checks. What I haven't seen here is there's no mention of a database backend of any kind, but I think what you were saying was that you could write your own application and use whichever backend you wanted to, rather than being tied to MySQL.
Yeah. So we don't have any database backend, but the backend module can use Postgres or MySQL.
Right. So we could use anything we wanted to rather than being tied to MySQL.
But the nice output is JSON, so you probably want to have a JSON store, really, to really use the results.
Okay, and that's why you're using MongoDB, for example.
Yes, exactly.
Okay, thanks.
But to answer your question about filters, we haven't implemented filters because you filter out the specific name server, right? Yeah, we haven't done that yet. Okay, thank you.
Thank you, Patrick. Next, we have a plan for decommissioning the DLV from Jim Martin.
And the beach ball. It's right there.
Which one?
It's right there. Yeah, actually, let me make sure. Yeah, it's the right one.
There you go.
Good afternoon. So what I want to sort of brief people on is what we're thinking about at ISC with regard to sunsetting the DLV. So just a quick bit of background for anybody who's not familiar with it. DLV was developed many, many years ago, in 2006, in fact, to get around the problem of the newly developed DNSSEC, finally, the reboot of it. There was not a lot of impetus for people to sign their zones because there wasn't a clean way to actually validate it because it wasn't signed to the root. And there wasn't a lot of impetus to sign the root because there were no zones that would be validated. And so to get around this chicken and egg problem, the DNSSEC look-aside validator was developed. And at that point, the only CCTLD that was signed was .SE. And so this allowed people to put their own zones into the DLV, and now you could validate. But since then, a lot has happened. Many CCTLDs were signing through the end of the aughts. We finally got the root signed in 2010. COM and EDU and NET have all happened since. And perhaps most importantly, all the registrars are now being required to provide mechanisms for you to get your DS records in. And then the validating resolvers are well distributed to this point. So we're sort of at a point where there's a real question with 642 TLDs that are validating at this point, that are signed rather, is there really a purpose to having DLV any longer? So the advantage of having DLV is that it allows the sign zone to be validated no matter what. That's great. And that you know you've got one place where you can put DS records and they will be accepted for free. That's all been good. The downside, though, is that it reduces the pressure for any parents that have not been signed to actually get around to signing. It reduces pressure on registrars to actually allow DS records to easily go into their web interfaces and such. And it requires an extra round trip to go to the DLV servers. And it also puts yet another point in the system where there could be something that would break down and cause issues. The current need for DLV is specifically just for those people who don't have a parent that is signed. If your parent is signed and your registrar will accept DS records, then you're good to go. The number of unsigned parent zones is going down dramatically, and the registrars that don't accept DS records are low and are getting lower because the 2013 ICANN Registrar Accreditation Agreement requires that they accept it. Those agreements run for 5 years, so by 2018, everybody is contractually required to do so. There are some corner cases where it's still useful for someone who's moving from one registrar to another, and you can't time it perfectly, and you need to get the DS records in where being able to validate through the DLV is useful. Those corner cases exist, but the truth is, we believe that the negative impact that we're having on the deployment of DNSSEC is more of an issue than the impact of these issues on individuals. The registrar support for DS records has grown dramatically, and a lot of them will accept DS records via email if they won't do it through their web interface. And frankly, we believe that if shutting down DLV causes people to switch registrars, that it will be a forcing function for the registrars to actually implement more easy mechanisms for this to be available. So the real question is, have we met all the criteria that makes it ready to sunset DLV? Is the root signed? Yep. About 80% of the TLDs are signed and have trust rankers in the root. And we believe that the number of registrars supporting DNSSEC in validation for child domains is large enough to be able to move forward. And really, part of what I'm doing here today is to get feedback, to get if people really believe that this is a bad idea or a good idea. The plan at this point, moving forward, is that we're going to start by cleaning up the zones. Currently, there are about 4,500 zones in the DLV. Of that, only about 2,800 of them are actually working. They're fully configured and working. The best part of that is only 400 of them that are in there have an unsigned parent. So everybody but 400 could potentially be properly signed up to the root. Currently, of those 4,500, 20% of them already fully validate. They just happen to be both in DLV and signed up to the root. So our plan is to go through, figure out who's in what category, figure out who can be validated, or rather, who could validate all the way to the root, who has a parent that could potentially accept their DS records, and send out email and notify everybody. A lot of people probably put their information in the DLV years ago and haven't thought about it in a long time. So we're going to give people a heads up now. Over time, we're going to stop adding new zones if they could be validated up to the root, saying go do it the right way, don't use DLV. And eventually the intent is to remove all the zones. The timeline on that is right now, we're doing the analysis and expect to be sending out the email for those folks that already can validate all the way up using normal DNSSEC. We'll let them know this in the next month or two. Similarly, if you could go through, set up proper DNSSEC, but you just for whatever reason have not, we're going to send an email to try to nudge people on. What we're doing right now is just notifications, no actual changes. The intention then at the beginning of 2016 is that if you could be validated all the way up to the root, we won't let you add the zone to DLV. Okay, go do it the right way. And then at the beginning of 2017, we will say that no new users can be added or zones registered with DLV at all, new or old. And the idea is that if it could be validated outside of DLV, we've told you a year and a half ago that this was the case, we will purge those records. And then mid-2017, we'll just get rid of everything with the idea that, yes, we are going to unfortunately screw some folks over, and we recognize that from the beginning. However, we believe that this is enough notice and enough time to push people towards doing the right thing that we can then get this out of the way. The dlv.isc.org zone will stick around forever so that there will be an answer for it, but it'll just be an SOA. We're out talking to folks now, trying to let people know. We've talked at ICANN. I'm talking here. I'll have a more basic presentation for RIPE, and also we're talking to other operator meetings. We're trying to get an idea of what people think of this, if they think this is a terrible idea or if this is a great idea. We're going to be notifying everybody who's using DLV right now. And we're going to go to the validating resolver publishers as well as the OS packagers to figure out where defaults should change over time. And so really what we're looking for here is feedback on whether this is a good idea, bad idea, and just an idea of what does the community believe. And so comes the herd. I knew this was going to happen. Lehman, what can I do for you?
You're way behind.
Okay. We should not have asked for this to be a lightning talk. I'm sorry.
So this is Lars Lehmann from NetNode. Let me express my warmest and most heartfelt support for this.
Thank you.
This should go away.
And that's what all the rest of you want to say too. We just sit down and make it really quick. Okay.
I have a quick question. Do you intend to remove the code from the bind distribution as well?
That is something further down the road. And remember that DLV is a concept. Then there's the DLV registry, which ISC runs. Mm-hmm. What we're really talking about here, specifically in this presentation, is shutting down that registry.
Right.
The code is something that is going to be discussed as a separate thing because there are certainly special use cases where people want it.
Okay, thanks.
Stefan Bartmeyer, AFNIC. Big thanks to ISC for DLV. It was a very good idea. It helped a lot for the deployment of DNSSEC. So that's perfect. Congratulations.
Great.
But now things are really different. So yeah, I agree with the deprecation plan that you suggested.
Great, thank you.
Jim Reid speaking for myself. Jim, again, think it's a great idea. It's long overdue, and I'm delighted to hear that DLV is eventually going to go away. I'd like him to also reinforce what Lehman had suggested there, that there should be a statement as well about removing the DLV code from bind as well. I think we have to make it very clear to everybody that if this is to go away, it's going to go away for good. In my own personal opinion, this stuff needs to be dumped at the bottom of the Marianas Trench, surrounded by lots of sharks with mind control lasers to make sure it never ever surfaces again.
No.
Peter Koch-Dienig, I wholeheartedly appreciate ISC running the service and terminating it. Maybe the timeline is negotiable to get it out of the door a bit quicker. The reason for is, there needs to be room for improvement, guys. The reason for this is that new validator operators need to get a message somehow. So you ask for who to talk to, especially, that is, put a warning somewhere that now jumping into the boat is probably not the right idea. Mm-hmm. It's not only about those people already running it, but prevent others from getting on.
It's not just that we don't want it to be a checkbox item. We want it actively not to be a checkbox item as new things are developed.
Yeah, right. What I was referring to, everybody's looking at how many zones are, or how many domains are in the DLV.isc.org zone. The consumer part is more important here because they are the ones suffering from the illusion because there's nothing to be in anymore. But thank you. Yes.
Matthijs, Dine, not a +1, I guess, for decommissioning this, but also a little bit follow up on what Peter says. Can we do this a little bit quicker? I was wondering how many people do still register something in DLV?
How many, you mean the rate of registrations at this point?
Yeah, currently.
Well, to be honest with you, I can give you a little bit of data on that. The numbers that I quoted here, I know that at this point it is just over 5,000. I cheated here because this was a set of slides that was generated about 2 months ago, and I only had some of the new numbers, so I didn't want to make it internally inconsistent. But I know that there have been 300 or so zones that have been registered in the last couple of months. But that was for a small number of new entrants.
Right. Okay. It's higher than I expected. But anyway, I was what I wanted to suggest is to move the step to register new clients in the DLV up front, so you don't grow this number and you don't have to clean up so much afterwards.
Okay.
Olar Wimson Klausler. I would love to say kill it now. I propose the following modification. You don't accept anybody starting next month that it can be validated globally. And you have everybody who has an entry in there log in to your user interface once a year to keep it alive.
We're definitely doing the user cleanup, where basically checking to see if anything's been alive. And are you proposing that if you don't log in once a year that we remove the record?
Exactly. I think they will all be gone in a year.
All right.
Hi, Jim. Dwayne Wessels. On your slide of pluses and minuses, there was a minus which I didn't think I saw, which I would call like information leakage. So people who have DLV configured in their recursors are sending you data, and so I know you're sort of stuck in the position of having to run the zone forever now. And I think it would be good if you don't already, maybe there's something you could say about that data that will be sent to you forever from people who don't know that they need to unconfigure DLV in their recursors.
You're saying
right?
that we're not going to be abusing the data that comes to us about what records are being looked up?
Right. I mean, I admit that I don't know what your policy is at this point in time, but
we treat it the same as we treat the root.
Yeah.
Yeah.
Okay. Thanks.
Hi, well, thanks for running this. We bootstrapped UA DNSSEC using DLV, and I killed this thing inside a long time ago. And I would say anybody who's using DLV knows they're using something that is just a scaffolding. Once you build a house, you remove the scaffolding. And can you show me the number slide again, please? It's three forward, right? No,
There we
one.
go.
Yeah, right. So look, it's like only 10% actually are in unsigned parent. So those are actual folks that need it. Messages that maybe you do publish that list. I don't know, unless your user agreement did not permit. I'm talking about the 397 number, or maybe about the whole number. As a last resort, I don't know if somebody is not getting the message throughout the channels.
I think that there's a chance that we will accelerate this if after we email people there's a big removal of zones or telling us to remove the zones. We're just trying really hard not to provide a lot of surprise to administrators that didn't even realize that their predecessor put this in, and that they really should have been doing this the right way.
That's what I'm saying. Assuming that somebody who put the zone is no longer there, if the administrator is using DLV and I just want to check if they have like an account with you, they can just look up their domain name. So I'm just saying publish the list of those domain names,
Okay.
the full list and the 397 list. And I would say, no, those are really small numbers.
Yeah, there's none of this is
So
difficult.
either nobody needed DLV or it was 90% success. Yeah, and that's pretty much it.
Thank you. Delta.
Hey, Jim.
Jelte from SIDN here. I have actually several questions. I hope I'm lost in line. The first is, do you also have any numbers about the people sending you those queries? Because I have seen more and more resolvers that don't actually even use DLV anymore.
So unfortunately, because we wanted to make sure that it wasn't entirely dependent on ISC infrastructure, the folks at Affilius and Newstar will also answer the queries. So we can only tell you about the slice of ours. However, we can tell you that that it is certainly the largest set of queries against ISC.org. Except the any ones, but
Okay.
we all know about those.
Yeah, well, I've seen those as well. And the other one regarding the information leak, you might do at one point even consider breaking the clients that are still sending you these queries in like 2 years or 3 years after it's been shut down.
We have to be careful about that because you've got to understand what impact that's going to have. Yeah.
And I also have one question to the room, actually. Will all of those of you that have these strong words about killing this right now, please use those same words to the registrars and few TLDs that still don't support DNSSEC? Thank you.
All right. All right. Thank you, Jim. Next, we have ANSSI DNS guidelines from Florian Maury again.
Hello again. So this presentation goal is to present a document that we have written at ANSI. There is hardly anything new in this document. We are not trying to provide new recommendations regarding DNS security. The goal of this document was to write a documentation meeting our criteria. As I told earlier that we are providing information about different types of attacks and also different kinds of, in general, configuration recommendation. And we didn't find any documentation that were meeting these criteria. That is, to have a document that is written in French, of course, because most of our operators are not actually fluent in English. We wanted also a document that is independent from the DNS community. I think it is interesting to have a governmental organization providing recommendations that are very similar to what the DNS community is providing, while being independent in terms of that we have nothing to sell. And we also wanted a documentation that is that have an all-in-one approach in terms of architecture and general organizational and policy. We also observed that incidents keep on occurring, so we wanted to document all the things so that at least our operators can know about it. And that was also the type of documentation that is asked by our operators so that they can point to it as a reference. And they can then sort of blame us for implemented best practices. Because sometimes the best practices create complaints from their customers. So the guide is using a risk management oriented approach. That is that we are documenting a lot of vigilance points that the domain name holders have to take into account when they are contracting with a provider. And to do that, we have adopted a broad approach where we are dealing with organizational aspects, legal aspects, and also technical aspects, all in that one document. And for each of our recommendations, we're trying to provide a few DNS essentials for them to understand why we recommend that sort of thing. So on the organizational part, we document that selecting a registry is not only a marketing choice, but also a security choice, because the registry security is paramount. to the actual security of the domain name. And since registries are high priority targets for the attacker, the choice is really important. And on top of all the availability best practices that can be implemented by the registries, we recommend to select a registry that has the following security features. Of course, the DNSSEC support, and the registry lock. We have a particular vision of the registry lock, so I'll just explain what I mean by registry lock. By registry lock, I mean that all information related to the zone are frozen, and that includes delegations, the DNSSEC materials, and the whois content. And the lock is activated by the domain holder and enforced by the registry. That means that the registrar cannot do anything at all, because the only way to unlock the registry, to unlock the registry lock, is to have an authenticated request from the domain name holder that is verified by the registry. The same thing applies to the registrar, whose security is as important as the registry selection. Precisely because sometimes if you don't take into account the registry lock, the registrar can meddle with the DNSSEC informations. So we recommend to select a registrar which has registry lock support, DNSSEC support, and offers a two-factor authentication in his web interface administration page, and also access logs to this administration page. Concerning the other providers, we recommend to either do self-hosting, or if you are contracting with DNS hosting operators, to verify and put into the contract all the technical best practices that you want to be put into operations. And concerning the other types of providers, such as the resellers, we just document the fact that contracting with someone is not dealing with the risk. It's only transferring the risk to someone else. So you have to handle with the contract all the things to ensure that the risk is actually handled correctly. Concerning the legal aspects, we provide several lawsuits resolution. I'm not sure of the word. We give examples of what is actually told by the law, and we recommend to select a registry and a registrar that are subject to a legal system and a dispute resolution policy that is well understood by the domain name holder, and that often means to select a registrar and a registry in that is speaking the same language as at least the law department. Concerning the technical aspects, there is very obvious recommendations, that is to implement a backup policy, automate system health checking, and to set sensible TTL values and to not override them. That's for the resolver part, because often TTL values implement a policy with good reason to select this TTL, so we try to convey this message. We also recommend to be simply compliant with the state of the art, that is to support TCP and EDNS 0. I've seen many studies where the EDNS 0 is still not supported, or TCP is sometimes by some security firm told as being an error of configuration. So we recommend to support both of these protocols or options. Concerning the system hardening to deploy DDoS mitigation solutions, such as namely response rate limiting, we also recommend to harden the operating systems and not only the DNS soft service, because it would be a problem if only the DNS service is secure, because it's then easier just to hack the system in general, and to implement also role separation. I mean, we recommend to have an authoritative server that is only serving authoritative data, and a resolver that is only doing the resolution, the recursive part of the DNS server. that allows to protect yourself from attacks that affects only one part of the daemon. We also recommend to implement information compartmentalization, that is to have your private data, if privacy is a concern in your DNS zone, in a separate daemon, such that in order to have a protection in case of memory corruption, where you can leak your data through the interface that is listening to on a public network. Of course, that means also that we recommend not to use views, except if they are used to respond different things on a geographical base, and not from a security and privacy perspective. We also recommend to avoid single points of failures. That means implementing software diversification and adopt a resilient network and physical topology. And that was posted on the mailing list last week. We recommend to avoid glueless delegations when they bring with them additional threats. I mean by that if your delegation, if by using a glueless delegation you introduce a new actor that can fail and therefore create an availability issue with your domain, then you maybe should use only glued delegation. Not sure that was very clear, but well, the questions are there for that. Regarding DNSSEC, it was brought up on the mailing list that we are not giving recommendations to implement DNSSEC in this guide. The truth is, DNSSEC is fine, of course, but we think it is only interesting to consider to implement it if all of the previous recommendations are already applied. DNSSEC is quite involving, and the other recommendations are quite easy to implement, and they are not implemented by some operators. So first have that implemented, and then you can consider DNSSEC. And we have other documents produced by ANSI, for instance, by the Residency Observatory that I've talked about before, that tell people to study DNSSEC and its deployment and deploy it eventually. So, as I told you, the goal of this presentation is to get feedbacks from the DNS community about our recommendations. Maybe they are off. And also to know if there is an interest in having this type of document translated in English, because as I said earlier, it is currently only written in French. Thank you very much.
All right.
Okay.
Thank you, Florian. Oh, wait. Too slow.
Hi, my name is Roy Arendt from Nominet. Not about this presentation, but on your previous presentation, I want to apologize for my unnecessary and undeserved remark. So here are my apologies. Cheers. Thank you.
That was no problem. Thank you very much.
Thanks. Okay. Next up, we have Sebastian Castro with popularity ranking for domains based on DNS traffic.
One short remark. And I think you're aware of that, but I think this work is also relevant for the RIPE community. So you might shoot it in, probably it's too late for the next one, this week, but for next RIPE meeting, the DNS Hub or the best current operational practices task force.
Yeah.
Thank you.
Thank you very much.
Thanks. All right. Come on up, Sebastian.
Hi, I'm Sebastian Castro from the Museum and Registry Services. I have a gift for anyone interested in making a question at the end of the presentation.
a copy of the domain names for dummies, which says everything you need to know about domain names and how to use them. That's the kind of documents we send to the registrars, by the way. We got some promotional material and we send out to registrars as a gift. Anyway, my presentation is not about the domain names for dummies. It's a popularity ranking for domain names. This is a proof of concept that mix up some techniques from text mining techniques into the DNS traffic, and we got some interesting results. So the concept we are going to apply here is the TF-IDF statistical method, which stands for team frequency and inverse document frequency. So TF is the number of times you find a word in a certain document, any document, any language. And the IDF is the inverse function of the number of documents that a word is in. So mixed together, you can actually go and count the number of words in a document and then count the number of documents that have that word in order to find out which words are relevant for a given document. And that information is usually used in search engines in order to go and narrow down the list of words you can actually go and look for. So the point is, what if we try this on authoritative DNS data? So instead of words, we use a query name, and instead of documents, we use the set of queries sent by a given IP address. So from now on, you will see D is a query name. So A, the lowercase a, is a source address, and uppercase A is all the unique source addresses we see in the traffic. So some mathematical formulas prepared with LaTeX. So wow, it's been a long time. So we calculate the term frequency for a given query name and from a given address as the count of queries we got for that query name divided by the number of queries sent by that address in a period of time. So the period of time in this case is a day. We calculate the IDF as the log of the number of total number of addresses divided by the total number of addresses that sent a query for that given name. And then we have the TF-IDF, which is a multiplication, the product of those two. So with that score, we can actually go and create a ranking of domain names for a given address. And that ranking will give us, the top one will be, okay, that domain, that query was relevant for that address. So if we go and merge all the information, all the relevant ranking for all the addresses on a given period of time, using the formula you can see here, we can actually go and prepare a ranking for all domain names in certain ranges. So nothing better than a pretty picture, although this looks a little bit overloaded. In the next slide, you will see the actual, that visualization is available there. So this first one is for the popular domain names. So we went and picked up more or less the top 20 most popular domain names across the .NZ namespace in March of this year. So you can see on the top, Staff is one of the newspapers. New Zealand Herald is another newspaper. And you will see on number 10, ODT is another newspaper. So one for Auckland, one for Wellington, one for Dunedin and the South Island. You see travel website, Expedia, Trivago there. SIG is a site to look for jobs. You can see a few of the government sites. So Teara is Maori language resource from the government. Immigration is the immigration department. You also see RRD, if I recall correctly. You see the appearance of the ANC Cricket World. So during the March was the Cricket World Cup in New Zealand, so there was like traffic related to that. We have on number 18, we have Radio New Zealand, which is one of the you see it's a top 20 visited site and the assigned domain, which is really nice, and stuff like that. So you can see through this visualization the changes in ranking. So there is kind of a group of domain names on top that don't change much, and then there is the spaghetti, complete spaghetti. So we did the same for banks, just for the sake of it, just for a proof of concept. So we have 11 different sites for banks in New Zealand, so ANZ, BNZ, Westpac, HSBC, etc. So again, we have like the top 4 that bring out the traffic, and then middle group, and then the bottom. Using something that's available in New Zealand and Australia, which is an ANSI code, is an industry code, we can actually go and group traffic for certain domain names based on industry. So we're going to go and build up on that idea. So the visualization you just saw, that's a screenshot, is what called a bump chart. So it shows the evolution of ranking across time, and it's inspired on that URL you see there, but we have to go and more or less implemented it from the scratch because there was no code available. So we will make our code available at some point, and we will keep playing with this. So because this is a proof of concept, there are some stuff we noticed that might get wrong. So for example, some bias toward like big sites, or some bias towards domain names or query names that have low TTLs. So that's something we still need to evaluate. The other thing we want to try is actually all the combination of query names and query types, and compare this to ground truth. So that means go and check the number of visits of a web page, given web page, compare it to what we see on our data, and see how far are we. In some cases, there are some addresses, I was having this discussion yesterday, there are some addresses that are from known resolvers. So we might give them a little bit of higher weight on this ranking calculation because they come from trusted sources. But in general, because the model is normalized, so across the whole pool of addresses that send queries to us, it's we don't see likely that 1 or 2 addresses will skew the results. And actually, when I was presenting this concept to a student from university, he went to the command line, started writing, and sent like 200 queries for the same name to one of our name servers. And he asked me, so that screw up your numbers? And I said, no, it won't. But he was like very clever in order to go and identify that idea on the spot. We might give it a try to the concept from VeriSign, I think was like 2 or 3 OARC meetings ago, about using source address clustering based on the traffic patterns. And as I said, make the code available for analysis. So thank you very much for your time. And if you want a domain names for dummies book, the mic is waiting for you.
So Warren Kamari, can you go back to the list, the pretty graph?
The not so pretty,
Yes.
or the so pretty?
And can you explain why so many of the queries are for people trying to find travel out of New Zealand and jobs?
Well, finding jobs will be in New Zealand. Traveling away from New Zealand, no, I won't dare to say anything about that.
You've done this on full qualified domain names, correct?
Yep.
Have you thought about doing it on the actual, registered domain?
Yeah, yes, I've thought of that. And actually, we tested the technique on using resolver data as well.
And did it kind of work?
For the resolver data, it didn't work because it requires some cleanup. So, for example, things like the Facebook CDN, they use domain sharding, so they screw up some of the results. But with a little bit of scrubbing, I have the hope that will work. And for fully qualified domain names, actually, so we did this for government, and government actually compared the internal results with this, and it was like very spot on. So I'm not completely sure it will work 100% across all the range of different domain names, but we will work with some of them.
Okay, thanks.
I'll give away the books later. Thank you.
All right. Thanks, Sebastian. Next up, we have real-time analytics applied to DNS traffic traces from Francisco Cifuentes.
Okay. Hello, my name is Francisco Cifuentes. I work at Nictile Research Labs, and I'm going to give a lightning talk about a new project that we have started recently. It's about doing real-time analytics of DNS packets using the Apache Storm framework. Okay, so what's the start of the state of the art of DNS monitoring? It can be summarized with these three tools, DSC, NG, Hedgehog, and Bumblebee. The first two are excellent DSC presenters. They use the DSC collector data. Bumblebee, on the other hand, does real-time analysis, but as far as we know, it is close to Nominet network. So what's this is a simplified view of DSC system architecture. So first we capture the packets and with the DSC collector, and then we save them every 60 seconds into an XML file. And then a cron job take this file and sends it to the DSC presenter, which does all the classification algorithms and show it in a pretty way. So, I show this because we are going to do something that resembles this. So, before that, I'm going to give a little description of what's Apache Storm. Well, Apache Storm is a framework developed by Twitter that it's used to do real-time computation using distributed systems. It has many use cases such as real-time analytics, online machine learning, continuous computation, etc., and has been used in many companies such as Spotify, Yahoo, Twitter, VeriSign, and many others. In the DNS world, it has been used by VeriSign to detect and mitigate cyber attacks, as we saw yesterday. And we want to do something similar to this, but in another way. So this is what we are proposing to do, and we are doing actually. So we, as the DSC architecture that we've seen before, we have the parser. We capture the packets and let them go through a parser that transform the packet into the JSON format. The JSON format, we choose the JSON format because of the availability of libraries and easy debugging. And then the parser send them the message to a Q middleware, such as Kafka or RabbitMQ. We send the message compressed with the LZ4 algorithm, which is very fast. So it doesn't add so much weight to the whole network. Then the Apache Storm framework starts distributing the job and took every message and does some analysis on it. Here we have some of the analysis that we propose. The first is doing QName analysis. We want to do some kind of static and dynamic query names analysis, and this can be useful to resolvers to deploy a catch with the first names of this ranking. Also, we want to do load balancing analysis, so that can be helpful to our DNS admins. And finally, we want to do server location versus query source location analysis, where we want to see the distance, the geographic distance between the clients and the server, so we can help our sysadmins to check if their routes are okay. Finally, we want to implement DSC collector plugin, so it can be used by the regular DSC presenters. And also we want to do some new stream-based visualization. Here we have some inspiration images where that they have used stream-based visualization. Here we have real-time emoji use tracker on Twitter, that each row in those cells, on these tables, each cell on this table represents the usage number of those symbols on the whole Twitter system. And this is showed in real time and updated in real time. So we want to do two visualizations that resemble this one. The first is the query name ranking, where each cell is going now to represent a name, and we want to see them updating in real time and going up to in the ranking, so we can deploy better catches. Also, we want to do another visualization that resembles this one, that is doing each cell of this graph. It's going to be a server in a cloud, so we can check if the load balancing is working okay. It's working right. So another mockup that we have worked on is to use the Google Maps API or OpenStreetMaps API. So we can check in real time if some pair client's queries server response is higher than some threshold of higher distance. I'm sorry, the distance between the clients and the server reach some threshold that it can be pre-configured previously. So why do we need real-time analysis? Because with this, we can help our DNS admins to take even better and faster decisions by reducing the delay in the DNS monitoring. We can help them, for example, to mitigate DDoS attacks. And why Apache Storm? Because it is a proven framework used on the hardest use cases. And what we have done until now, we have done the DNS packet parser. It is multi-threaded and does the compression part with the LC4 algorithm. And we have tested the throughput of this parser through different topologies. And we measured that its throughput is about 25,000 DNS packets per second. So it doesn't have any I can't remember. It keeps being a lightweight protocol as DNS is. Okay. So that is suggestions and ideas are accepted, and thank you.
Hi, Roy Adams, Nominet. You happened to mention Bumblebee. You said Bumblebee appears to be closed to Nominet network. The data that Bumblebee produces, that's actually close to Nominet's network. The tool is commercially available, but I just want to make it clear that the data is something that we don't share.
Okay.
So, thank you.
Thank you.
All right, any other questions? Thank you, Francisco. And before the break, before we leave for the break, I'm going to hand it back over to Keith too.
So before we break for coffee, can I ask Roy Ahrens and Antoine Verscheren to come up to the front, please? This was supposed to be a surprise for all concerned. I'm afraid that it's been fumbled in various ways, but that doesn't undermine the sentiment of appreciation that we want to show to former board directors. So, Andre, do you want to do the honors? So, thank you to Roy and Antoine and Matt and everybody else. They're specially engraved ashtrays. Okay, it's great. We're actually slightly ahead of schedule. So let's resume at the advertised time at 3:45. Get a slightly longer break. Okay, we are ready to get restarted again. If everyone could please sit down. Okay, final session. So there's only an hour and a half between you and beer and other ripe activities. I'd like to introduce you to our final session chair of the workshop, again on the program committee, Liam Hines.
Hello. All right. First up will be Bert Hubert, who will be talking about DNS dist, which is a DNS latency and DOS-aware load balancer.
Do I need to do anything?
Yep. Just press.
Thank you very much. So I have the great pleasure of starting 10 minutes early, which means I will be talking 10 minutes longer. So I hope you'll enjoy that. This is the story of DNS dist. And sometimes you start a project and you don't know where it takes you. And halfway through you wonder if you want to get there. And that's DNS dist. And it's also called, do we need a DNS delivery controller? And I hope you can help me answer that question. Very briefly, what is Power DNS? Where do we come from? We've historically not been going to enough of these meetings. And even yesterday, we were approached by someone that said, oh, wow, you're actually a company. We've been a company for 15 years. We started out as closed source, didn't work very well. In 2002, we went open source, and we kept on maintaining the project. At least I kept on maintaining the project. And then in 2006, we started offering commercial support again. And recently, we've become joined forces with the Dovecot IMAP server, and we're now part of the German company Open Exchange, and that's great because they have wonderful salespeople, and that allows me to fully focus on code. So that's why I'm here. So Power DNS can serve data from anywhere to anywhere, and the Power DNS recursor is a resolver and strives to be a no-worry, high-performance, robust resolver. And finally, and I would like to draw your attention to this, we have lots of interesting tooling that is not Power DNS specific, but could still help you in your work, like DNS replay, DNS dist itself, DNS scope makes statistics, Kali DNS is a calibrated query generator, so there's stuff in there even if you're not a Power DNS user. So what's the story of DNS dist? We had a requirement that we were migrating a server and we wanted to just send all the DNS traffic from one IP address to the other. And this all sounds very simple and turns out to be 2 error-prone lines of IP tables to make this happen. And so we thought, well, let's just make this small DNS dist tool, which you can say, listen on this IP address and distribute any DNS queries you get to the following N IP addresses. And we built that 2 years ago and it worked for our migration purposes. And then I think maybe 6 months ago or something like that, we were working together with Patrick Wallström here also with a Swedish customer that was having big Power DNS issues. They do happen. So we gave them all these new versions of Power DNS to run, some of them still warm from GitHub, and they were okay with that, because they had a very good load balancing setup. It made them confident enough to just swap out one of their servers, try another one, and even if it crashed, that was fine with them. And from that, we appreciated how much fun it is to have a good load balancer in front of your name servers. So we asked around, because people always ask us, can you recommend a good load balancer for DNS? And so then we ask people, and they always say, yeah, well, we have this machine from vendor F or vendor C or vendor J, and they all say, yeah, well, it works, but we are, no one will recommend their own load balancer. No one says, yeah, we're really happy with that. So then we said, well, maybe there's something special about DNS. Maybe there's something that we should be doing. No, the honest truth is I just felt like writing a new piece of code. But okay, so we did. So we wrote DNS dist, and I used the word delivery controller, which is a word that really comes from the enterprise world of software. And there they are sort of convinced that you can no longer just put a server on the network. There always has to be something in front of that adds SSL and security and graphs and other things. Sort of an article of faith there. So we decided to do the same thing. So we built this DNS dist, and it's a runtime configurable from a console. So you can connect to it, type commands, query rates, everything. We added tab completion, so it has a really nice interface. And the console and configuration are actually in the wonderful Lua programming language. You don't really notice that because it's just a command line interface where you program the stuff. But if you know it, then suddenly you can actually run programs in there. And then we built a whole suite of load balancing policies that are actually rather well suited for DNS. But when we were at it, we also made the possibility to block traffic or to send traffic in different directions or shape it into a configurable QPS limit. And we wrote these policies in C++ where they're fast. But since we already had this Lua on board, we also made it possible to write these policies in Lua. And then people might say, oh, maybe that's not fast enough for my application. Well, trust me, usually it is. So we added simple load balancing, quarantining of infected customers. And one other thing we did, we wanted to make sure that DNS dist is not a part of Power DNS. We want to make sure that this is something that everyone can use. So we try to be vendor neutral and not tie it to Power DNS in any special ways. This is a DNS load balancer. It's not a Power DNS load balancer. So what did we got back as feedback from people on existing load balancers? They said, well, they're very good at HTTP and HTTPS. Maybe IMAP, if you're lucky. But DNS is sufficiently weird that you cannot treat it as a sort of retarded HTTP. Yet this is what many load balancer vendors do. The other weird thing we found was that whereas normal load balancers will try to spread the load as evenly as possible over all your servers. And for DNS, that is not the optimal solution. So if you have 10 servers, each doing 1,000 queries per second, your users get worse performance than if you had one server doing 10,000 queries per second. Because all the caches are hot, everything responds quickly. And this is not something you will find in a normal load balancing policy, because if you do this with a web server and you put 10,000 people on one server, they're not happy. So we wrote this concentrating load balancing, and just to keep this for real, we did some tests. And like I said yesterday, we love doing tests, especially in production. And so with two companies, one in Sweden, one in Belgium, we shut down maybe 75% of their name servers and concentrated everything on one server to see what would happen. And happiness happened. So even though the query rates went up by a factor of 4, maybe per server, the actual CPU load did not go up by a factor of 4, not by a long shot. And this is both for authoritative and recursive service. So it's very sublinear. And in the end, we had one server in Belgium doing the traffic of millions of cable modems. And it's physically sort of scary idea that you have one unit height doing all that stuff, but it worked. And the other was one name server doing 700,000 domains with online DNSSEC signing. And yeah, I can only say everything was better when we concentrated the traffic. So what would such a configuration look like in DNS dist? I hope you can read it. So we have various load balancing policies, round robin, hashed, so that the same query always ends up on the same server. Weighted random. Least outstanding is a nice one. That's sort of the automatic policy where if you have 5 servers and all 5 of them have, maybe a few of them have 100 queries in the air that they're dealing with, and one of them has only 90 queries in the air that they're dealing with, we will send the traffic to the server that has the least number of outstanding queries. This is very nice when you fire up a name server and the cache is cold. It cannot yet handle the full load of traffic. And this way it will sort of amp up the load. But this is a configuration that's actually rather interesting. It sends 1 query per second to a Google public DNS over IPv6. It sends 1 further query per second to the other address of Google. It sends 10 queries per second to OpenDNS over IPv6 and another 20 queries per second to the other IPv6 address. And everything that does not fit in those QPS limits goes to the last server. So if you have this configuration and you say, well, my first server can handle 30,000 queries per second. My second server can also handle 30,000 queries per second and whatever. In this configuration, all your traffic will go to the first server that still has room available within its queries per second setting. And this delivers this concentrating load balancing solution where you have 10 servers, of which 9 are doing absolutely nothing. And 1 is providing stellar service and very high response speeds to your users. Interestingly, I have to rate limit Google Public DNS at 1 query per second because at 2 queries per second, it starts dropping my traffic. I'm not sure if I offended anyone there, but that's how it is. The Open DNS people will happily eat 20,000 queries per second from me. So that's nice. Conceptually, this is on my screen, this is a lovely blue color. Here it looks rather sad. So this is the concept we have. You have pools of servers. And you can say, this is my main resolver pool, and they all can do 30,000 queries per second. I might have a special DNSSEC resolver pool where all queries that have a DO bit set get sent to that pool. And I might have an abuse pool, more about which later. And when you configure this, it says policy first available. If it's a troubled domain or a troubled source of packets, then we send them to the abuse pool. If there's any hint of DNSSEC in the query, then we send it to the DNSSEC pool. And otherwise, the main pool is used, and the first server that has not hit its QPS limit gets the packet. And of course, we also have to deal with all the QPS limits being exceeded, and in that case, we turn into a stupid load balancer again and just do a round robin. So I will not belabor the point. We've been speaking all day or 2 days now about these reflection attacks on random domain names. The solution we propose is first get a name server that can deal with that. But even then, the idea is to make a list of your users that are actually open relays. This is typically, I heard some numbers like 1 in 500, 1 in 200 of the user base, and send them to a dedicated abuse pool. And there they can degrade the performance of the other people with open relays. So they can soil their own nest and cause their own trouble. And then the people that are not infected have clean name servers. We tried this a little bit, and it's incredibly effective. And it also helps you with the dirty or the nasty choice of having to pick if you're going to kill a domain name or not. In this case, you say, no, the domain name, well, we'll do our best, but we'll just have a separate pool of servers for you with the old Pentium 2 server in it. So this works, yeah, it isolates the bad people from the good people. While we were at it, we added a number of other things because we thought if we are going to be in this place where we have a chance to study packets and drop them or move them around, let's make that easy. So you can make policy decisions based on any of the header bits of a DNS packet. We also extract the DNSSEC flags from the opt record at the end, which is, try doing that in IP tables. You can filter on domain names or on suffixes. You can use regular expressions if you want, or just simply filter on source address. One of the other things we added, and that was a specific feature request, and that also speaks a little bit as to why people would want a DNS load balancer. We were approached by some very nice people that said, look, we have this enormous DNS server farm behind us, and it does not support sending any queries back truncated. So it does not support any to TCP. And we're not going to be able to change our giant server farm because it's a legacy thing. Could you please add this to DNS dist? And from our end, it's very easy to do. If we see in any query, we just send back a TC is one answer. So this is now one of the options we have, allowing you to sort of resurrect your old name server farm. Yesterday I also mentioned PowerDNS 2.9, which just refuses to die. There's a painful bug in there that has to do with truncation. And we also built a small feature in DNS dist that we will fix up this ancient bug for you, thereby not helping the world in getting us rid of PowerDNS 2.9. But there you go. Finally, sometimes you also have customers that just keep sending you the same query or a weird query, and you say, well, I'm going to try a few things to see if I can give them an answer that will shut them up. And this too you can do from DNS dist. So some other things we added, live statistics, built-in web server with moving graphs up to the second. And I have to admit, I have not yet found an operational reason for this. But does it look cool? So this is actually all live. Well, actually it's recorded because of the demo. But here you can see the amount of traffic, the amount of queries per second to each of your configured servers and the CPU load and whatever. And this looks pretty cool. And this is operationally more relevant, although hard to read on this screen. Does it work? Yeah, it works. So this is where you can query in real time and say, look, show me the top 10 queries that I'm getting, or the top 20 or 200. In the middle, this is the top responses with error code 2, which is serve-fail, and you can see those. And finally, for example, you can also group them and say, I want to see this grouped by the last 2 labels of a domain name to see the source where my pain is coming from. And we already see some of the famous 888 domain names in there. And finally, this again has little operational use, but it's very cool. This is a histogram of the response times you get from your servers. And this is a happy situation. It could also be a very unhappy situation, and then the graph would be lower. So getting back to the presentation. So we have these statistics, the top N queries, top N clients, top N serve-fail generating queries or clients and whatever. And you can very easily see if you have a troublesome client, you can just block them or rate limit them all real time from the command line. And the last bullet is, because we have all this powerful Lua runtime, if you want to block all domain names with a prime number in there, finally you can. But we added this so that people have the maximum amount of flexibility. So what are people using this for or wanting to use it for? One is the TC is one redirection of any queries because their back-end systems do not support it, and the front end can be more flexible since it's not connected to all the business logic. The second big item, and that's a scary one, is that people say, yeah, people tell us that we should do DNSSEC validation on our resolver, but we don't want to actually turn that on our resolver because it's scary. So we'll put DNS disks in front of our resolvers. If we see a question that has anything to do with DNSSEC, then we'll send it to these 2 DNSSEC enabled servers that we have. And this generates the nirvana for a telco that they can say, yeah, we do DNSSEC validation, but only if you ask for it. And which means that they get no help desk calls. They don't actually have to have any people looking at the log files and stuff. So it's a sort of nirvana for the telco operator, but it's not actually good for universal DNSSEC validation. So it's a double-edged sword. Some people want to have these cool latency graphs, which I also have here, by the way. Let me see. I forgot those. It's always fun to type this in real time. So here you can get latency graphs from your server farm, and if this is all red, then your servers are too slow. And these are nice statistics to have, and if you just plug in DNS dist between your name servers and the internet, you get these graphs for free. So you can get actual latency graphs that are very difficult to measure from the name server itself, because the name server itself is not in the right place to measure its own latency. So people are proposing to run DNS dist just to get the graphs. And the final point is, of course, that I mentioned is the undisconnectable nuisance customer that sends you these queries that stress out your name server, but since it costs you 50 euros to contact that customer, you're not going to do it. And this allows you to shunt those customers to the difficult people pool. So, ending my presentation, this is an exciting and fun piece of technology, but it's rapidly turning into a name server. That means that if you want to do this kind of stuff, of course, we already had the question: could you add a little cache to DNS dist? And we all know where that goes. So you have a pure load. You could have a pure load balancer that does nothing but forward packets from A to B, and there's clearly a role for that. You can also have a name server that is fully featured enough to do this kind of load balancing itself. So you can get a long way if you configure a name server with forwarders. It does quite a bit of this already. So the question really is there room for something in between, something that's not quite a name server, does only minimal parsing, but still has these cool features that you need? And lots of people tell us, yes, there is an actual need for this. And of course, we have fun writing this, but we're not quite sure if this is something that should be done. And it's instructive to compare, for example, Apache and Squid and Varnish. Apache did everything, also had a caching module and a proxying module. But in the end, it turned out that it was far better to put the proxying part in Varnish and not turn that into a web server itself, of course, although it eventually did. So it does appear there is a sort of niche for the software that sits in front. And with that, yeah, we'd like to have some guidance from you, from the audience maybe. Is this a good idea, and should we be doing this? Thank you.
Stefan Lagerholm from Microsoft. I think this is a great idea. I think it's looks like some cool features in there. I'm a little bit worried about the DNSSEC piece when you only serve the people that are actually asking for DNSSEC, because you could, I mean, you'd be better off serving everybody even if they are non-DNSSEC aware. I mean, I think that's one of the beauty with the DNSSEC, that you can turn on for everybody. I also see kind of a downgrade attack on the, if you have that abuse, I can spoof my neighbor, and he's going to be moved in there and maybe lose DNSSEC and other features that you have in the main resolver. So I think there's some small kinks there that perhaps needs some more work. But other than that, I like the concept.
Okay, thank you. I think maybe in brief response, one reason we do this is that the amount of staff that is dedicated to working on DNS at access providers is extremely limited, ridiculously limited, like 1 person per 5 million subscribers, that kind of limited. And this is a sort of response to that personnel shortage to at least allow them to do some DNSSEC. But thank you.
Matt Weinberg from VeriSign. I think this is fantastic. Good job.
Thank you.
One question I have you didn't mention is performance. Have you done any performance checks on this, and how many packets we're talking about per second on a commodity box?
Yeah. So the easy answer is it does around 100,000 queries per second, which is a bad number and a good number. It's enough for most people, but it's not actually fulfilling the role of getting a load balancer to allow you to scale horizontally. Because in that case, you would want to have something that does 1 million queries per second. But as stated before, it's hard to do that kind of thing on PC hardware. So the goal we have for this solution is to at least function in the neighborhood of 150,000 queries per second. And out of the box, it does get there if your server is actually willing to go there.
Hi, it's Shane Kerr from the Beijing Internet Institute. I actually had a question when you talked about hot caches being good. I saw on like the next or 2 slides later that you do have a hashed way to distribute queries. It seems like what you really want to keep your caches relevant is the hashed responses with lots of servers instead of limiting the number of servers. Is that reasonable?
It's actually, we implemented that in PowerDNS itself. PowerDNS itself, each thread is its own thing. And there's a sort of internal hashed load balancer in front of that. Right. And that worked tremendously well, like 30% lower.
I remember the article about it, yeah.
And that was, we should have done that a lot earlier. We have tried it, how much the effect is, but it turns out that you still get these huge CNAME chains. And within those chains, you get these TTLs that do expire. So the gain of doing this is not as big as it could be.
Okay.
But the option is there, and it's also easy to measure.
So I think this is really cool, and I think it's also really useful for people doing things, distributing queries within their networks instead of just within a cluster. I do think, I don't know, is there capabilities to inspect the distributor from outside? Like, yes. Like, okay. Yeah, special queue names and things like that. I might have missed it.
No, that's actually, it's, so if you look at this, this live graph, this one is actually live, by the way. There was a rumor going around that the actual DNS OARC traffic is on here, but that's not true. This is a replay of a denial of service attack, which is great for testing. All this you see, this is polled using a JSON RESTful interface. So you can poll DNS dist directly.
Okay.
And inspect it and talk to it. So it's not
Okay.
quite DNS native, but you can talk to
yeah,
it.
if it's your network, that's fine. Yeah. Okay, cool. Thank you.
Hi, Dwayne Wessels from VeriSign. Could you say a little bit about how DNS dist supports TCP, DNS over TCP?
Yeah, it supports it very well, and that's it's actually an interesting a nasty problem. It's far more difficult to load balance TCP. What we do is we hold open a number of connections to all our backends, to all the backend servers. We spawn more of these connections as we need them, and then we when a TCP/IP question comes in on the front end, we use one of the already open and available TCP/IP connections to the backend to answer it. And again, we pick the server to talk to using the same selection rules that we use for the pools and everything. A very open question is, should we be using one TCP/IP connection and multiplexing queries over it? Should we have multiple outstanding questions at the same time and supporting them, the answers arriving in the wrong order? We haven't done that yet. And the other open issue that we have with TCP/IP is the zone transfer problem, because now the name server sees the IP address of DNS dist.
Yeah.
So you need to filter the access to zone transfers on the front end all of a sudden, and that sucks.
Yeah.
Yeah.
So are you supporting connection reuse on the client side also, client to DNS dist?
Yeah, you can also keep it open.
Okay,
Yeah.
cool, thanks.
Jelte Jansen from SIDN. This reminds me more of Nginx than Varnish as a retarded HTTP thing. But, and I definitely agree that you've started building a new name server. And I also think that that's a good thing actually, because even the lightweight name servers have become less lightweight. And this seems like it has the potential of being like Nginx, something you can put in front of arbitrary things of your own making even. And I would wholeheartedly support that. So kudos for making this.
Thank you.
Peter Koch, DNIC. I really like this. Something like that has been on my Christmas wish list. One of the problems is I have 1, 2, or even 3 ideas for another set of features. And you mentioned that on your very last slide. So there is a potential to fall victim to your own success. Do you have any idea about how to guide the architecture, maybe by an ultra-conservative architectural board or something, so that you don't that you don't suffer from this? Because the next in line is, of course, everybody liked this. You will go around and collect money, and people might want to influence this and so on and so forth. I would. But what's your vision about the architecture there?
Actually, that's a big reason why I'm standing here, is to help form that vision, to see if we can find something. So a clear reason, for example, is you do something in the load balancer that the name server itself cannot do. So if the answer is the name server cannot do it, for example, it cannot honestly measure its own latency, then it's good to say, okay, it's going to be in the front end. But there is a sort of sliding argument there, because this small cache that people, they really tell me they have convincing reasons why they want that. So we have an easier criterion for, yes, this should go in because the name server cannot do it, than for, no, we're not going to do it because, but we should maybe form some principles. I don't know, something that says, look, maybe the whole thing should be less than 10,000 lines of code. Maybe that is something that we can stick to. It would be very long lines eventually.
Yeah, I was going to say, think of obfuscated C contest or something. Okay, thank you.
Greg Chills, 3UK. Can you build a time machine and send this back 10 years, please? The other thing was regarding your pool of real servers. How do you decide how capable a given server is? Is it static configuration or does it learn?
So we have multiple modes. So we have a pretty stupid way of determining. So first we determine if the backend is up or not, because if it's down, then we take it out of consideration at all. If it is up, then we have a policy that says, okay, we're only going to send you a query unless you don't have too many outstanding queries already. And that one is actually self-learning. So you can see from this actual live graph that the Google public DNS is only getting a very small amount of traffic because it's not sending us sufficient answers. That is because it sucks. But it's automatically rate limited down because it's not sending us answers. And there's no smarts behind it. It's just, yeah, there are other servers that have a smaller amount of queries outstanding. So it does learn.
So if you're slow, we'll just wind back a bit.
Yeah.
Okay, thank you.
Hi, Matt Larson-Dine. Add me to the list of people voting for a small cache in front of it. I understand it's a slippery slope. I understand the desire to not want to do that, but I think the potential for clever and hopefully not evil things is really increased by that. Imagine geographically distributed servers that are farther away, and on if you're willing to tolerate some latency on a cache miss, but then keep the cache on this thing hot. So things like, that's just the first thing I can think of. I think that increased the utility a lot.
Well, one of the interesting things, thank you for that. One of the interesting things, it turns out that even a very small cache has a pretty decent cache hit rate. So maybe, okay, I'm convinced.
Hi, Ray Bellis, now ISC. If you get UDP in on the outside, is it UDP inside or TCP inside?
No, it's UDP stays UDP, TCP stays TCP.
Okay. Have you considered potentially bridging between the two? Will there be any benefit in doing so?
No, we are a nice bridge between IPv6 and IPv4. Okay. So that works really well. Yeah, okay, I really need to wind down now. But maybe, so to be honest, Power DNS does not do out of order TCP IP answers. So that's why we're a bit reluctant to expose this bug to the world over UDP. Okay, thank you very much. If you have any further questions, I'll be around later. Thanks.
All right, next we will have William from Canada try to remote back in, and he'll be talking about RSAC 02, and then we'll go straight into the AS 112 operational overview.
Yes, so we were running beautifully on time, and now we're about to blow it. So we're going to have another attempt at bringing in the OARC Ontario office. So if you just bear, we got this working at lunchtime, so if you just bear with us. We actually found a better solution than yesterday using worse technology.
Hello, William, are you with us?
Yep. Awesome. Excellent. Okay, let me just cue William's slides up. Okay, William, your slides are up and good to go.
All right, thanks, Keith. Can everybody hear me? Yes. Good afternoon, angels. All right. So I'll make this quick and painless for everybody. This is just a short overview of the efforts we're making on mirroring the RSAC 002 stats. So let's go past the first slide. So it's really just a baseline of metrics that have been generated as a result of an advisory published by the RSAC. And the recommendations are on the collection of data in a certain format. So it's pretty straightforward. What OARC is doing is simply mirroring that data from the sources that are publishing so far. So next slide. So there you can see some of the formats that this data is available on. So some of it's JSON, some of it's YAML, and section 4 goes into a little deeper. And you can read that document online at ICANN's website. Next slide. So this is what the data metrics look like as far as being collected. That's further defined in section 2. Next slide. So this is what we're mirroring so far that we've heard the community has made available. So A, J, and K, L. We've collected it in one spot, and we're doing it through a very rude set of scripts that goes off and does a wget on all the sites that publish the data. And it's available to researchers, available on a good analysis server near you, in one place, of course. And that's the directory tree. Next slide. So the mirror coverage is equal, we hope, as far as I've been able to determine, to what's been published so far. So A and J, far back as May 2013, that's what's been done. K started publishing in March 2015, L June 2014. And as we get to know about more collections being published, we'll mirror those and we'll let the members know that they're available as well. Next slide. So this is just a small set of observations on the data quality. And some of the collections vary. Some data is not found in the right place. Some data is missing. For example, some have published data for 1 day of 1 month instead of every day for. That might be a function of the collection at source. That might be a function of the collection frequency, shall we say. Maybe that was decided that's what best. Section 4.7 does define a path scheme that I use to mirror, and we try to mirror as much as we can that we know is there. Slide. So what does it look like? It varies, as you can see. If you try to go and look for some of this data, or let's say the zone size on a given day across the servers, you may or may not find the information as easily as you think. Same thing for our, so these are examples, but in all fairness to the root operators, operational priority trumps stuff. Okay, so that's the caveat there. Next slide. Now, this is the juicy stuff for next time. And the end. Any questions?
Okay, before we do any questions, just be aware that there's a 30-second lag on the video feed. So if you have any questions, we'll relay them back to William via instant messaging. And any questions about William's RSAC 002 presentation? Okay, in that case, we will proceed to his next talk.
Yeah, Keith, there's no lag to talk to William.
No, but if somebody stands up and puts a, there is on the audio back. Yeah.
He's in a phone call, he can hear it, right? It's on Skype.
Yeah, but he doesn't. Okay. Well, we'll see how that goes. Okay, William, we're good to go.
All right. So just an update on AS112. Quite a number of updates. Slide 2. So it's just an overview of what AS112 is. I think most people are familiar with what the project entails and the goal of the project. So this should not be new for anyone. Next slide, please. So a couple of updates, major updates for operators to take note about. RFC 6304, which defines AS112 operations, has been updated and obsoleted by a to-be-published RFC, tentatively 7534. It adds IPv6, adds some prefixes to the ANSI special use registry, both the AS number and V4 blocks. There's another one by our colleagues, led by Joe and Warren, on DNAME delegation. The issue there is how do we tell existing operators, hey, put these zones there. This informational RFC proposes how to go about getting around that issue. So both of them passed working group last fall. They're both in off 48 with the RFC editor. Too late to speak up, whoever holds the peace, the marriage has gone through. Next slide. So some things to note for people who operate such nodes. You're expected to answer on IPv6, and you should follow any new directions in the new RFC. There are also new IPv4 and IPv6 blocks prefixes for DNAME. So you want to keep those two in mind. You should be using those two documents in tandem if you're going to be standing up an AS112 service. Interestingly enough, when P6 was turned up, we were getting queries for junk from V4NAT. So it's nice to know that there's some dual stacking going on. Next slide. And this is the effect. Merely just a few minutes after the V6 prefix was turned up at one particular node, you can see in the green there's IPv6 traffic already. Bizarre as that is. Next slide. So for a number of years, I've been doing a bunch of surveys on AS12. What motivated it is to try and figure out a way of updating the web page that lists the official operators. That page is not complete. It's not even accurate. It's representative. Is there a way to make it more representative, more accurate? So there's a couple of ways. Open DNS resolvers are actually very, very useful. It'd be a very sad day if we eliminated all those. No, I'm just kidding. Route views is good for finding globally routable nodes. In some cases, some nodes are only visible at IXPs. And interestingly enough, if you know your geography, there is one in New Caledonia, and good for them. Next slide. So this is some eye candy, just to give you an idea of all the open resolver versions that are out there. Billions and billions served. Next slide. So how did I do the survey? I didn't use route views in this case because it gives a limited scope. But I tried to automate it, run it once a year, and this is the methodology I use for the open resolvers. Next slide. So this is a list of open resolvers that I have from Jared Mock, about 7.5 million allegedly open, and almost in response. And I get all sorts of interesting feedback in trying where all of these are. And not just the results in particular, but the nodes themselves. And by client count, it looks like the one that Ivan operates in Paris is the #1 global. And note that I use the word nodes very, very loosely here. All right, next slide. So what do we have as a choice for open resolvers? And there at the top, 10, 9, and you can see who are the ones that are globally routable and popular by far for these open resolvers. So I ask our open resolver, who's your nearest AS12? And this is pretty much what I get. And it's useful because I have records of AS112 nodes defined. This is not the accurate though either. So this is not a perfect way of trying to discern where AS112 servers live, but it gives a fairly good idea. Next slide. So I talked about this, and what about the operators listing the website? Well, no. It's an interesting test versus what I found out for the clients, but I was surprised by the result. Next slide. So in 2014, you should see a map with red markers, and that's what the ops listing says is out there for AS12 nodes. If we go to the next slide, the 2014 survey said, too far off. So next slide, they're largely the same as you saw visually. But what gets more interesting is what is out there in terms of how these guys have reached. But I would need more data on a ditto collection layer or separate data for all the AS112 operators, so that way proximities can be configured better. To that end, though, it just so happens I have a very good guinea pig, and this is a long-winded example that follows. Next slide. So let's talk about the end. Those are the national research and education networks, the global in scope. Completely separate internet. I use the word completely loosely. You'll see why in a minute. We have BGP tables for these advanced research networks at around 16,000 subscribers. That's a very small subset of total internet. That's the whole point. This is a set of research networks for researchers away from the big bang and all the now humans extending themselves. So, interesting question is, how many root servers are there? That's for a researcher to find out. I kind of know the answer, but that's not the point of this presentation. What happens if we have an SQL server on a research and academic network, on an NREM? Do queries link between the internet and those networks? What's the reach? Can we use an AS112 node connected in such a manner to discern what the client reach is? Next slide. So here's an overview of what the NREMs are like. So you're in Amsterdam, connected to Light, very good chance you're connected to Jean, but maybe not privatizing. That's a peering issue, that's a policy issue. But there you see the global scope, everybody's there. Connected to the bottom right, to the left, Canary, Internet 2, yes, no. Next slide. So I decided to find that out of the data set that I already had for looking for global AS112 nodes, how many clients are on the NREMs? And you look at this map on slide 17 of open resolvers, and you find, oh, it's not much. That's pretty good, isn't it? Next slide. A picture is not necessarily worth 1,000 words. There were about 3,000 open resolvers clustered in a number of groups. I would say they were on campuses, judging from the IP ranges. And there was a lot of consistency within the campuses. So I guess, let's give it a hand for consistent IT policy. Mind you, on a high-speed research network, what a delicious opportunity for attack surface. So, what does it tell us about the clients, though? Not the open resolvers, clients on the research network. Next slide. If I'm looking at who is using a particular AS112 node, all sorts of questions arise. I know for a fact from experience that research networks tend to be quite leaky. Not everything is self-contained. There is routing asymmetry that happens. There are secret handshakes and special projects and favors, all sorts of other delicious junk. But that's neither here nor there. I wanted to know how many clients are actually using one AS112 node in one part of a research network. I thought, probably the best reaches in the United States with Internet 2, and that's about it. Next slide. I was kind of wrong. This represents all the people, all the systems making junk queries to one AS112 node that is the only one known to be on the NREMs located in Canada. I would have to ask why people as far away as RNAP are using a node in Canada. So I think this speaks volumes about the lack of reach for NREMs as far as authoritative TLD or even root or even AS112 servers. All right, that's something to digest. I actually have this diagram live on the internet. People want to dive into it and see where their favorite nodes are, but these are all the clients using this one AS112 server that's the only one reachable on NREMs. Why is it? Next slide. Just for you guys, though, Here's your neighborhood. And you notice the UK, Republic of Ireland, Spain, Italy, there's no clients that's asking the Canadian AS112 node. Why is that? Do they have their own AS112? Is their peering really good to an IXP that does? Maybe they have no resolvers. Maybe they have really well configured, well-behaved user end stations that are brilliantly set up and maintained. I'm being ironic. Next slide. So I cover this a little bit. Germany's in there as well as not using the Canadian node. That's excellent. Good DNS, already said that. It becomes a more interesting exercise if you try to delve into the data a lot further and try and correlate this with UGP routing tables. And what will help is a longer-term study of the effectiveness, both from a user point of view and report point of view, and whether or not network symmetry or routing asymmetry all over time. But we can learn a lot. Next slide. So what can we conclude from this? I think I pretty much said it. We set up AS112 nodes, better peerings, better connectivity. You know, I saw clients, even on the internet side, asking to resolve queries to AS112 nodes, not even within our network. Went off to the States, for example. But for the end rents, the problem is a little more acute. Or we can just fix the DNS for everybody and help make AS112 obsolete. Next slide. I threw this slide in here rather on an inspiration, because how do you explain it to the suits? There's no suits in the room, no offense to the suits. I don't want to have a falling out with Armani or anything like that. But anyway, it's all very interesting, and you can try explaining this to this language, but I found that sometimes you just don't succeed. The technical barriers are too much. And sometimes people at that level, it's kind of tough to put into words. So why bother explaining it in words? Next slide. Just draw a picture. This is a representation of queries going to one AS112 node. It's interesting when you look at the visualization of just one node. I'm curious how it looks when you have a bunch of nodes. Next slide. So, being serious for a minute, this is the AS112 node by Automatic Genetic Syncs. And as you can see, each balloon represents queries coming from one source. And you have to wonder, is it because there's a really aggressive resolver, or is that a very, very big network sitting behind there that's just completely and consistently misconfigured? One has to wonder. But the best way to put it through that mindset is simply to say, that's you leaking that data. And we got to do something about it. And next slide. So what about the rest of the data? There's a lot of data. And I haven't even looked at the digital data from the various AS112 participants. I'm betting there's a gold mine there for myself as well as researchers. And all of that stuff is available through the analysis service for people that go in and have their own investigation. And that's it for me. The end.
Okay, thank you, William. Any questions for William? Okay, looks like we don't have any questions. Okay, thank you very much for that. We'll pass you on to the next presenter.
All right, this is Mr. Fujiwara. We're talking about update on increase of root and JP queries.
Hello, I'm Kazunori Fujiwara again. And today I will talk about increase of root and JP queries. And I would like to I would like to say long-term trends of number of queries. And DNS queries increasing. Some people say that the load to DNS is still increasing and queries to root and TLD DNS servers are also increasing. However, there is no evidence which indicates the increase of queries to root and TLD DNS servers. And I analyze DNS OARC root datasets and JP datasets. JP DNS servers have approximate 1.6 billion queries per day, and we have two datasets. Packet captures of all JP DNS servers around the same timing as DITL date event, and query logs of two JP DNS servers every day for 9 or 10 years. Then I counted the number of queries and average query per second. This graph shows average query per second seen at root DITL datasets. And the broken line shows linear approximations. The increased tendency was indicated. However, average query per second increased about 5 times in these 8 years. And this graph shows average query per second seen at each root DNS servers. And the broken lines show linear approximations. The increased tendency was indicated. However, average query per second increased about 5 times in 8 years, almost of the same as all DITL data. And this graph shows number of queries seen at JP, all JP DNS servers, 48 hours, 5 years. Sorry, I can't show the number of queries, the number value. The increased tendency was indicated. However, it is slightly lower than root. And this graph shows number of daily queries seen at ADNSJP and G.DNSJP. This graph shows that the increased tendency was indicated. However, average number of daily queries continuously increased about 5 times in these 10 years, I think. And there are fluctuations of data. Fluctuations of data comes from differences. For example, DDoS attacks and daily weekly changes. Days of a week are different on each DITL data, and captured number of routes varied on each DITL data sets. And the differences in the load tendencies by configuration changes. Any cache change adding NS in JP DNS case. And this is my conclusion. Queries to root DNS servers and JP DNS servers are continuously increasing. Average query per second seen at root increased about 5 times in these 8 years, and average query per second seen at JP increased about 5 times in these 10 years. However, the increased ratio of DNS queries is smaller than the increase of the internet traffic trends, shown by IX operators and broadband operators. I think the increase of DNS queries seen at root and JP is limited, except to those attacks. Then I'd like to know the DNS query trends seen at other edges, another TLDs, resolvers at ISPs, authoritative servers, or popular websites. Please show DNS strike trends observed by your organizations and discuss the future DNS strike trends. That's all. Thank you.
Fujiwara-san, thank you very much for your presentation. So two things I want to point out. Number one is, this is Mehmet, by the way, Microsoft. Number one is in 8 years, you mentioned in the earlier slide that there are about 8 times growth in the queries to the root servers. But I believe in this 8 year, there's also a lot of adoption of mirroring the root zone and significant growth in like the public resolvers such as Google, etc., which is known that they are actually not sending the queries out to the root servers. So when we look at this kind of research, I think we need to keep that in mind. A lot of people are actually mirroring the root zone this way or the other way. The number two is, I don't know how accurate the data that is on the DITL data that you were looking into, but when I was operating LRoot in 2013 and way before, the growth was significant. So I can't look back and remember and say what the growth looked like, but there was the graph that you show was pretty much how I experienced myself as well. So I want to back you up with that. Thank you.
Thank you. Root data increase is not high, I think, because DIT data storage size increase is limited. Sometimes, I think, and I heard. And please show your graph. Increase graph, please.
All right. Thank you.
Thank you.
Next up is Ed Lewis, who will be talking about an update on the DNS root key rollover.
Hello, my name is Ed Lewis, working for ICANN. There was a note up here about warning something here, but I think it's someone else's notes. It was not a warning to us. Standards will be bound. So I'm here to talk about some of the upcoming events with the root zone KSK. I have an agenda that I'm just going to start digging into. The background here, the root zone KSK is the trust anchor for the internet's DNSSEC. I'm referring to the key that most people will be putting into validators, and from there starting DNSSEC from the top down, DLV aside, and so on. This has been in production since June of 2010, so it's almost to the 5-year mark, real close to that. We've never changed that key. The KSK has not been changed for the root zone since then. And until a month ago, we hadn't even changed the HSM, the hardware security module, I consider like a critical pieces of hardware involved in all of this. So now after 5 years of operation, we're getting to the point where the HSMs were coming under comments that they might be getting too old. I'm getting too old for this, actually. So take that as you will. And also there is a requirement basically to run the KSK. So the players involved with this, there are 3 root zone managers. There's ICANN, which I'm working for. The NTIA, I wanted to spell out the entire name for those people out there. It's a really long one. I'm not going to read it because I can't read that far. And then there's also VeriSign, which is running part of this, the group of 3 here. In addition to these 3 folks who are running the DNSSEC in the root zone, we've also enlisted a design team of 7 people from the community to take a look at discussions about how to go ahead and do this. And I'm going to call some of them up on stage at the end of this and make this an interactive discussion. And also, I've been asked to say that ICANN is doing this work for the DNSSEC and the KSK under part of the IANA functions contract, one of the roles we do with the IANA work. I put the slide up here. I feel like I don't really need to go through it. KSK, it's the key signing key. It signs the DNS key set for a zone. The root zone one is the one that's going to be, the public part of that is put everywhere, that anyone who's going to do DNSSEC on the public internet is going to use that from the top of the tree down. The private part of that's used in HSM, is what's doing the signing of the key set alone, and that private key is going to be in these HSMs. HSM is a hardware security module. Its job is to make sure no one knows what that private key is. It never gets out of that unwrapped in plain text and so on. So I'm going to turn this around a bit. The HSM is the easier activity to talk about, so I'll talk about that first. What's the public impact? Why do we want to make sure you know about this? HSMs, they're part of the infrastructure. If they work, you will not know about them. If they don't work, you will know about them. Publicly, there have been some comments. People who've been watching this closely have said that the HSMs that we have are at the end of their warranty, and there's some concerns about the battery life getting to be a concern. If the batteries go bad, we just can't just get a new one and bring it in right away. So we want to address that. That's kind of a public perception problem, but it needs to be addressed. The KSK role is a much bigger impact on the public because anyone who's doing DNSSEC validation today and relying on it will have to follow along the change. If you don't, you will break. You will stop validating because the new key at some point is going to be used to sign things. The old key will go away. Everything to you will be bogus. So if you're using DNSSEC, you actually go to the back of the line now. Now everything's broken. If you weren't paying attention, you're still not paying attention. But this is a big impact because if you're participating here, you have to do something to stay involved, stay online, basically. Besides having to do something on your end, ICANN and the root zone managers and our job is to make sure that you know this new key is the new key. That's going to be very important. When the new key comes out, you want to be able to trust it. So we have to make sure you will know which is the right key and where to get it from. So the presentation I'm giving, and actually I'm already halfway through my slides, and now I'm going to tell you why I'm talking. I thought it was kind of ironic when I went through my slides. We want to inform you about what's going on. It's just a little advertisement of things going out there. But I also want to get reaction and feedback in what's going on, what's coming up here. I'm going to say we're going to bring up some of the design team members soon, and we'll have a little discussion about what might be concerns of folks. We're learning of things that we should consider as we go along right now. And we don't know everything to start with, so we're learning. Also, I want to advertise an event that is not yet scheduled. ICANN, as part of its processes, has a formal public comment period. We're going to use that to get more formal feedback on what's being presented here today, or what will be presented in the next couple of months. I want to make sure that if you are inclined to follow that or aware of that. I can't tell you when it's going to be yet because we haven't scheduled it, but that's definitely a place to make comments to make sure it gets heard by ICANN in a way that it will be necessarily responded to in some way. Now, there are two forms of feedback. There's the formal way I just mentioned, but there's also an informal way. At the microphone and mailing list, we as a group read mailing lists, we find things out there. It's informal though. So if it's said there, we'll try to learn about it, but we can't guarantee that we hear it. And so I'm just letting you know that whatever, and I said mailing list here, any mailing list that any of us are on, we look for things out there. Mailing list for whatever group is out there. DNS operations, for example, we'll listen to that for concerns too. HSM change. I said this was the first of two things we were doing, the HSMs. It's a straightforward replacement. We took the same brand of equipment, newer model, and we're going to just put them in place. There's actually a documented plan, which I have a URL to at the bottom if you want to go through the details of that. In April, we had a key ceremony, a KSK ceremony, that's part of the maintenance of the root zone DNSSEC. The script we had that day included the introduction of the two replacement HSMs for that facility to replace the two that are there right now. It went flawlessly. We followed the script perfectly. I think there was maybe one or two things we changed. One letter and an acronym was wrong. It was one of the exceptions. The other facility that we have is going to have the same thing happen in August, the middle of August. The they're staggered every 4 months for these activities. And so we'll have, at that point, new HSMs in place, and we've taken a little more care this time to make sure they're not made of the same batch and so on, for those who care about the actual manufacturing process. Now, the KSK role, it's a much greater impact, and there's a lot more ways to go about doing this, and so we've been spending more time reviewing what we're doing. Now, ICANN has, we had a public consultation already a couple of years ago on whether or not, or what to do about the KSK role. In 2013, there was an engineering effort amongst the root zone manager partners that came up with some plans that were then put aside for some time. And now this year, we've gone out and recruited people to come in and start with the question of, first of all, let's look at the old plans. Are they workable? Are they decent plans? They were well engineered, they just never got, they haven't progressed. Also looking at whatever concerns are out there. It's 2 years later, things change. The studies about the ECDSA, is that going to be, is that something that's going to help us out now that wasn't around a couple of years ago? Has the world changed enough that we want to do our assumptions on this entire system? So we're looking at these three steps. And the current design team plan right now is, they've been meeting for a couple of months. It's about the time of the IETF in Dallas. And we're continuing to meet every week. And sometime in June, we're going to wrap up the work, document it, and put it out for public comment. And we'll have at least a month or so for that. And then the design team is going to come back at the end of public comments and work in any things that come in at that point for a final report. And from that, a plan for going forward will be made. That's the simple, the high-level milestones for this. So the design team roster, the all-stars we have here, you can read the names here. You might recognize just about everybody out there. 4 of the folks are here. 3 are not. I guess that's simple addition. These are the folks in the public community who are out there listening to things, and they're going to help us with this plan. So before I launch into a discussion about this, in theory, a lot of KSK roles have happened out there. Anyone who's been watching this, KSK roles have been successful and unsuccessful. We actually know how they go bad, which is actually educational. And I threatened to call Paul Ebersman out, because every time they go bad, he gets phone calls. And I want to say, I'm sorry. So, they've gone bad, so we've learned what makes them go bad. Yeah, this is all good to have good and bad experience before you go into some major thing, especially if somebody else is bad. It's not always the case with somebody else. Anyway, now the root zone KSK is a little bit different from all the previous KSKs, because in most cases, you tell your parent, I'm changing the KSK, and you go forward, fine. In this case, we have to tell everybody that we have a new KSK. It's a little bit different. We do have some mitigating factor here that there's an RFC 5011, which talks about automated updates of the trust anchor set. We hope it works. Now, in practice, this is where the but should actually be if I read the slides. We have external challenges out here, and this is why we really want to make sure we get the community to know what's going on and get involved in making sure that we are looking at everything out there too. When we're doing this role, or the validator is going to get all the messages. We've talked about packet sizes. We've talked about fragmentation already. Is the automated update system actually going to work? One thing is, how do you test it? How do you actually test the updates occur? There's really been no way to tell if it's actually the updates were updated without changing the key and then finding out they didn't work. Will operators, the people who are running the networks, will they know what to do about it? Will they anticipate this and know what to do when Paul gets all the phone calls? Who's Paul going to call? And finally, will all these code paths work correctly? I've written code in DNSSEC, believe it or not, a couple of decades ago, and I didn't get this right. So I have a little bit nervous about this. So as I said, this is supposed to inform you and invite some participation. So I'd like to get the members of the team that are here, if you want to come up and help guide the conversation. John, Jeff, Andre, yep. And I have some bullet points up here, and I have some extra slides up here. And I'll run through the slides so if you haven't seen them, you'll know what's here. I've got the graphics of the role and the graphic on the size of the messages out there. So I'll let... Whoever wants to start. We haven't rehearsed this, by the way. Can't tell. So do you want, any one of you want to run through the? Or should,
I'll let you do it.
Okay, I'll do it.
Proposal by interpretive text.
I like it. You want to come do it? Okay, so we have some concerns with the design team, and I want to make sure this is actually a group effort. We're concerned about the message transfer units, the IPv4 and v6 fragment. We've actually discussed this earlier. Jeff was talking about this. RSA, the alternative algorithms, the ECDSA, 5011 trust anchor maintenance. And to kind of, I guess, now to paint some background, these colorful graphic slides were taken from the plan from 2013. And this shows the plan for bringing on the new key, which is not terribly far from most KSKs. And I won't go through the detail, of course, but in this case here, when we add the new KSK, we have a packet size increase, and this is actually leading into why we're concerned about that. We have a situation where we're rolling the KSK, but now we're rolling the ZSK also, because 5011 takes time to complete its mission, so it's going to overlap the changes of the ZSK, so we have another bump up in size. In this case here, we are concerned about starting to use the new key and then stopping using the old key. And at that point, stopping to use the old key is when Paul gets called, right? So Paul, you write that date down. And then finally, we have the concern about when this is all said and done, and in RFC 5011 in the Trust Anchor Management System approach, you're supposed to revoke the old key. But to save some time, basically, I guess there were two incentives here. One was to avoid a size increase at the wrong time, and also to put off burning the old key away forever as far as we could. We would just pull it from the zone and then put it back in to revoke it at some point in the future when we're sure things are working right. So this is the step 4, which I think is the last of the interesting steps. And then I'll leave this, and to the last graphic here, this is a look at today, what do TLDs do in terms of message size when you ask them for their DNS key? Because we've talked about this before, the size of that response is one of the most important things we're worried about. If it's too big, things will fall apart. Now, on this graphic here is a histogram account of who does what, or how many do what size. And actually, I have a mouse. This is 512. This is 1,500 bytes. I'll leave all the other numbers in here out because I don't even know where I want to put them anymore. This tall in the middle stands out for those who have 2K KSK, about a 1K ZSK with 2 signatures. That's where most of the TLDs by count of TLDs sit. And I should tell you, there's one outlier way out here. So, and one of the odd things was this one outlier, although they had to stumble eventually, the size of the set wasn't the problem. We knew about that, it was working fine, and something else happened. But in general, we see that there are a lot of those who are outside these numbers we expect to become problems. So the question is the size really that much of a limit? And I'll leave it to folks here who want to say something. Anyone? Or and then invite questions from the audience too.
Jakob Schlichter has done some work on this, and the issue comes at that point with the 2K key, the KSK, and the 1K ZSK. Just at that point there, you've got 2 KSKs. And that means that there's going to be a period where the response size jumps from where we are to just over 1,400. Now, for V4, theoretically, that's not a big issue. For V6, it's an issue. It's an issue because resolvers are setting 1280 on their sockets on one of the more popular implementations. And so they're running into this issue of either deliberately having to frag it or having to cope with truncated answers depending on how they're doing EDNS 0 size settings. What it also means, and Dwayne pointed at this morning, if you look at the distribution of EDNS 0 sizes being offered, as you increase the size of the payload, more and more folk are going to get a truncated answer, and it's going to be a reversion to TCP. So those are the kinds of issues that the size presents.
Ask a question. Okay, so in the team, I've been a bit more involved in the 5011 stuff on the previous slide. I don't know if I can make it. As I guess most people in this room know what 5011 is, and the big problem with 5011 is there's no signaling. So a validating resolver or whatever can't ask an authority server, are you running in 5011 mode with your keys? And you have to rely on the DPS or something else that's been published by the authority server operators. In the case of the root, the DPS says that they will use 5011 to roll the keys. That raises then the question of, well, how many people out there configured their trust anchors statically and didn't configure them as 5011 trust anchors? So I don't know if people in this room have any ideas about how well configured trust anchors are in name servers these days. There was a concern about servers that have been offline for a long time and have been turned on and won't work because they can't validate the 5011 rolled keys because they have been off so long they haven't seen the necessary 30-day rollover intervals and things like that. Personally, I'm not sure how much we should worry about that. If you're running a server that's been offline for months, maybe you should have to expect a bit of pain and have to go to some effort to patch your server when you bring it back up again. And then the final thing I can think of off the top of my head is there was a CVE bug in bind that's been recently patched to do with 5011 processing. As far as I'm aware, it doesn't actually affect a proper 5011 rollover. But if the 5011 rollover got bodged, or if someone was being malicious, then it could be exploited. But I don't think it would actually affect a proper well-run rollover from happening correctly. And I did do some testing in 2010 on Unbound and Bind and a sort of fake version of the root system, and it all seemed to work properly when we tested it back then. So I don't know if anyone's got any feedback on 5011 and whether people have actually configured their trust anchors properly.
And there's one more thing we found out. In case we would switch the algorithm, and when you add a new trust anchor to Unbound with different algorithm, you will need to sign at this point as well. Because Unbound is much more stricter when switching the algorithms, and it applies the same strategy to do trust anchors for root. So this could be changed in the source code, and well, the folks here can comment on that, but it's not going away from live because there are already deployments of Unbound that has this strictness inside. So in case the change to ECDSA happens, we probably need to sign at this moment to not break the Unbound deployments when the folks add new trust anchor with ECDSA.
Matthijs Dijn. So regarding the 5011, if I understand correctly, there's also some debate whether you need that second signature when you're going to revoke the old KSK, and that's a self-signed signature, which you actually don't need because the new key, the new KSK has already been a long time enough published that it is now a valid trust anchor, assuming 5011 implementation do it correctly. So it is a valid trust anchor, and now it can actually prove that when you set a revoke bit on the old key, that key is revoked, right? It has the authority to do that. So that self-signed signature is actually not needed, and you might be able to gain some size improvements there. That said, you still need to get that implementations ready, etc., etc. So not sure if there's time for that, but that would be nice. The second thing is a more bold thing to say, given all those size implications that you have and those problems. Have you considered to go, instead of a split, to go to a combined signing key, where you only have to have one key?
Thank you.
Like I said, we have.
Peter Gordinik, on the 5011 part, I think I understand that the question was, how do we find out how many might be affected?
Yeah.
Yeah, so...
and how much pain do we want to give?
Assuming that you can get to that number, and I'll have a remark on that later, how is the design team or anybody else going to decide how much pain is enough or is too much? And shouldn't that be specified before we look for the numbers?
Well, I think because of the DPS, there's a requirement.
Your mic doesn't work.
Because of the DPS that I can publish, there is a requirement to use 5011. So the role, I think, has to be some form of 5011. Might have a twist in it, might have a delayed revocation, but it's ultimately going to be 5011.
Okay.
And I think it's more a question of communicating to the people who need to fix their configurations than necessarily.
Well, fixed. Okay, let's take that. But still, if you send the impression, and at least that was what I received, that there is some measurement of damage impact, whatever the term is.
Well, I don't know how you measure it.
Yeah, then you might want to change this to avoid the impression that if 25%, X% are suffering, we're not going to do this. Now, let me go back to...
I didn't mean that. So.
No, you probably didn't mean it, but
yeah,
I might have misheard intentionally, but I actually didn't. Anyway, back to your response, people should go fix their configuration. I don't recall the discussions from back then, but it turns out that most of the time you would have to have this configuration part, trust anchor, writable by your name server software, right?
Yeah.
That might actually be in violation of corporate security policies. So there is a fix, but by fixing the configuration, I'm going to violate my corporate security policy.
Yes.
And that's a conflict that you probably cannot impose on people. No,
you're right. That is on our paperwork, on our documents on the ICANN wiki that we're writing. So we will be addressing that issue, but I don't know the answer.
Okay, I wasn't aware of that. Thank you.
Did you want to address? I was just going to make a quick comment back to Peter again about measuring pain. And part of the issue is, are we measuring resolvers or are we measuring the users that use resolvers? One of the weird things about the DNS is it is heavily concentrated. 2,000 sets of resolvers service around 95% of the visible user set. And so certain resolvers seem to have a lot of people behind them. You know, Paul knows about one of them. And they seem to be super duper critical. Others, and a lot of others, seem to have a very, very small population behind each of them. And I'm not saying they're super duper critical, because they're not, but they're not incidental either. You know, they're just part of the family. But if we can understand what those 2,000 resolvers that are, or resolver sets that are really important are doing, that would be a long, long way towards assurance. So
we know roughly who they are, but we don't know their 5011 capability in particular. So.
Shane Kerr, Beijing Internet Institute. I have a lot of stuff, sorry. I know it's a minor point that Ed brought up, but was there any discussion about looking at other HSM technologies? Like something less proprietary, maybe? Something like that? Something that hasn't been tampered with the NSA?
I don't actually know.
Okay.
I know that there was consideration of what to replace it with, but I don't know that. It was done by other people.
Fair enough. It's not a major issue. So we talked a lot about 5011. Could you go back like 1 or 2 slides?
Sure.
Yeah, here. Is it possible just to sign the ZSK during this rollover period and not roll it to limit to 3 signatures there? I know the ZSK is smaller, but seems like it could be done. I don't know how strict the policies are.
Yeah, I'd just say it's possible probably, but it may, we actually have some other requirements acting on here. In fact, I will address what Matthias asked about common signing. Right now, we don't have that option because of the structure of the root zone management partners and all that. I don't know if, I don't know if we want to talk about ZSK stalling a role of that. I know that at least I thought of that too.
Right.
But for some reason and I forget why, but that's not on the table.
It's not the biggest packet.
Yeah.
It's the next slide.
Yeah. So.
The next slide is the biggest.
But in terms of ZSK role, we've looked at that assuming that's going to be a consistent drumbeat through the process.
Okay. Okay. Well, I guess what my final thing will be is that we have started the Yeti project, and one of our explicit goals is to look at rolling the KSK more often, rolling the ZSK more often. So we're going to be doing some research into that starting now, basically. So if you have specific questions, we would love to have those submitted just as research efforts for us, and we'll have a look.
Roy Adams, Nominet. I've got a few crazy ideas that I just want to throw in the group. You've probably heard about Rick Roll and with a twist and all of this stuff. I'd like the one key thing. It's like Rick Roll with a twist and a cherry on top. Anyway, I seriously like the one key thing. Another thing in terms of algorithm role, I know that might not be on the table, and I know we've discussed ECDSA, etc., etc. But in theory, at least is what the standards say, but I'm asking the DNSSEC experts here. It is actually possible to basically have a completely ECDSA zone, ECDSA KSK, ECDSA ZSK, but having an RSA signature over that whole blob with an RSA trust anchor. You can basically do the entire roll without rolling the trust anchor. Is that an idea?
It's an idea. Sorry, right? I would say, as a protocol engineer, I'm thinking about whether that's possible from the protocol point of view. I'd have to think about it before I give you an answer if it's possible.
Well, that's why I think in theory it should work. But the other thing is, Warren and I were just discussing this. There's also this is also one of these bad ideas, but you can actually roll to the same key. I mean, in the theory, nothing has changed eventually, but you have done the entire roll process, if that makes any sense. So you can basically fill the pipe. You can basically test all the mechanics without actually breaking stuff first. So there's a whole bunch. This is what I understand we also did for the, or what they also did for the, for when DNSSEC was first deployed in the root. You had the unverifiable DNSSEC key, the DIRS key. You can do the same thing here. You can just do all the procedures, fill the entire pipe, use the public infrastructure for all I care, but don't just change that trust anchor yet. But do everything go through the motions. I think that should be part of the process as well.
Yeah, just to save time here, we have actually discussed doing that. And I can tell you later.
Perfect. Tell me later. Thank you.
I would just also add, those are good ideas, but they are theoretical. And I'm a bit afraid that the implementations will get creative when they will encounter this setup. But we were discussing setting a test lab that you can access with probably VPN or something, and we can test all those possible scenarios on different IP addresses or something like that. So we'll try that. Thank you for the suggestions.
I jumped to queue, Matthijs, Dine. I'm confused, rolling to the same key. I asked Warren, but I'm going to ask it to public now. Does that mean the same DNS key? And if so, that's a duplicate, so that should be removed before you sign the key. So how are you going to... Okay, well, coming right up.
So Warren Kamari, 3 really quick things. If folk want to test their 5011 code, and this isn't directed at you, this is at everyone else, myself and Rick Lamb both have systems that roll a sort of virtual trust anchor periodically. Mine does it every 90 minutes. I think Rick's does it every 15 or something. So if you have an implementation and want to test to see if your 5011 code actually works, point it at one of our things.
What's the URL?
Mine's keyroll.systems, and I can't remember what Rick's is. I decided, I should test these new GTLD things, and it actually worked. Oliver Goodmanson suggests, you could also use something like CDS instead of 5011, which means that you don't have to have duplicate keys or larger packets at any size. Basically, periodically, resolvers would just query for a CDS record. If there is a CDS record, they would just import the key. And now you never have to have the double signing thing. So basically 5011, but not have multiple keys in single response. And I can't remember what the last one was. Oh yes, Jeff, reaching the top big resolvers to see whether their 5011 stuff will work. I suspect those aren't going to be that much of a problem because the big resolver people are paying attention. And so when the big keys come out, or when you need to remove the old trust anchor, hopefully they will have already heard this. And so, hopefully the big folk will survive.
Warren, has Google already taken over all resolvers in the world? Because the implementation isn't the problem, the deployment is. Basically for for CDS or 5011, that you have all those binds and unbounds and perhaps bind force somewhere in the wild, and it's very hard to upgrade them. So
Yes.
this is the main problem we are
Well, I
facing.
think that this is for in the future. It would be a much longer term solution, not for this role. Because, if you have problems with big keys now and you've got crappy old things, you're screwed with that.
You suppose you will take over all the resolvers in the world? Cool.
I mean, eventually we'll be the only resolver, so it doesn't really matter what you do.
That would help.
Well, Dmitry, I just wanted to make kind of a comment, which is, okay, it's good that it's happening before the any transition is done, right? Because we'd never know. Okay, now I have this question. I'm looking at this all and I'm thinking, okay, when things would go wrong, what's exactly going to roll back? Where are your points, like in any plan, we say, okay, if this breaks at this point, we go back to step, or we continue forward because, or where is the point of no return here?
Who says call Paul? Sorry, Paul. I just want to make sure you're paying attention. No, so actually, one of the key deliverables here is to have a fallback plan. And right now, I don't want to debate just to save time, but not debate or discuss, really. But yeah, the fallback plan is a integral part of what has to be delivered here. And actually, that's why the delayed revocation from 5011 is actually on at this step here, so that we can go back to the 2010. We call it the 2010 key, if we need to, if things are melting down and Paul's busy as on vacation or something.
Right.
So it's in consideration. We just are not presenting that detail.
Yeah, not on this slide for sure. Maybe I'm not looking careful. Okay, cool. When do you expect to complete the planning work, including that?
The milestones for the design team is to have essentially a draft version of this prepared for the public comment middle of June, and the public comment into July, and then in July to August to clean up.
That's after the Buenos Aires meeting then.
The public comment should be this. It should be at the same time. I mean, the Buenos Aires meeting will be in the middle of the public comment period.
Yeah, but it would finish, comment period would finish, okay.
I don't know how the rules of public comment period, I need to review them, but I think they are extended when they overlap a ICANN
Yeah, they
meeting.
can extend that. I'm more worried about the transition. Okay, but thanks.
Sure. Yeah.
Hello. So I don't believe that it's a discussion about that there will be no damage. And so it has become the classic Winston Churchill, now madam, we're just dickering about the price conversation. So the formalism, or maybe it was Oscar Wilde, but Wilde and Churchill are the same person, aren't they? But there is a quality about, if it's about hurting people, you actually will have to encounter formalisms of ranking them. And this is a notoriously risk-averse space. So the likelihood of someone in the lawyer space being prepared to accept any statement of unavoidable damage is an interesting question. But nonetheless, reality asserts. I mean, you said yourself, what happens to a box that was previously validating? It was turned off and put on a shelf for more than 30, and then it comes back on again. I mean, definitionally, there will be one. It's a global network. There's millions of things. So the quality of the point where you put your finger in the air and say, this is a rough estimate of the likely damages, their rankings, the pain, the consequences, the mitigation, that's going to be very interesting.
Mm-hmm. Yeah, I was going to have in here a quote from Jeff Houston saying, things will break.
Yeah.
But for some reason, that didn't want to kind of give that impression on the slides.
So I actually liked the question, although there isn't an official signal of 5011, is there an attribute that could be done from packet inspection or behaviors at a system level that would tell us it was 5011? I mean, I have no idea what it could be. Like the sign twice with the same key and detect what it does or doesn't do because of a known behavior in the code base before and after that point. So the quality of anything at all whatsoever that would signal likely to do 5011, or a statement like any version of bind after date X had a certain behavior in the packet sequencing numbers, therefore by determination statistically, this many are 5011 enabled. It's not definitive, it would be incredibly useful. So I would like to understand, is there anything that's a signature that could say post the deployment of 5011 enabled code in bind?
I would say that it's not clear to me yet that there is.
But it's not clear there isn't.
Right. I'm saying nothing
There are
obvious.
no knowns,
I'll say nothing
there are
obvious has
no
popped up.
unknowns.
Yeah.
To answer George, this is all going from Cloudflare. To answer George's question, if you run 5,000, sorry, 5011, thank you. And then wait. And you have one record somewhere in the root zone that is only signed by the new key, you can check if that validates. No zone signing key signature on it, only the new root key. If you get that out, validate it.
I'm trying to, I know that I was in a conversation where we talked about doing that. I'm not sure. Anyway, I'm just not sure if there's an answer to that, yes or no, but yeah.
One of the problems that we saw about 5 years ago with rollover and die was these obsessive resolvers that when they couldn't validate, they tried all of the other NSs up all of the path and just thrashed around until every last combination had been checked.
Yeah.
So the new behavior, people, your bloody code, not mine, is to take a no and run. They don't check any other name servers. So if you make one of your name servers serve a new key and you don't like it, in the new behavior, they die, don't they? It's kind of, we had behavior that was kind of tolerant of what you're suggesting, and because of its sort of crappy side effects, a lot of resolvers, and I know Google's, for example, is the first no is no, just walk away. They don't check other name servers when they get a no. And that's kind of, I don't know how widespread that is, but that's, sorry, I do know how widespread that is. I just haven't looked. Okay.
You need to talk to your other personalities.
So I will tell you, because I think I may have misunderstood your suggestion. I was thinking of another case where you treat the trust anchor set as keys that are not actually in the zone. I think that wouldn't work, because I talked to Mike and John's about it. He said that they're treated as DS records, not keys, so I can't rely on them to validate. So we could talk.
And Warren misunderstood me. I said run CTS in parallel, not instead of the 11. And yes, you did.
I didn't mean to.
And you can run it for a year.
That's what I wrote down.
Really?
Yes.
Oh, well, thank you. So Steve Crocker suggested something a while back for solving a different problem, and I thought that sounded like a bad idea. But the more I think about it, the more it sounds like it might not be. What about having resolvers actually include some sort of information in their queries as a general thing that says sort of what version they are?
Yes! Sorry, please.
I mean, obviously there's some scary things with privacy, etc. So you could turn it off if you wanted. But there have been a number of instances now where actually having an idea of what the world looks like and who supports what would be useful.
Tell that's options negotiation.
And then another bad idea, Ferry. Have we discussed having 2 copies of the root zone, and some servers serve one with the new increased key, 5011, and the other set still have the other one? So that way there's not too much breakage? Was it? Oh, I was too busy having other conversations.
Well, Warren, we discussed having this set of new root servers behind some VPN, where you will connect it using some public key, and it will push you the routes to existing root servers. So we will get the new information if you connect to the VPN, so you can test the deployment.
Okay, so that's not, I remember that conversation. That's not what I was suggesting.
Okay.
Change one over, run that on just one, leave the rest alone. Yes.
Okay, yeah, that's what I suggested.
I think that's the twist in Rick Rollover with a twist, isn't it?
Basically, I want to close the mic line real soon because we're at the end of the time where you don't have beer.
All right. So I did work on signing the root zone a little bit, as you guys know. So I want to answer a few questions, if you don't mind. Yep. Mehmet, Microsoft XICAN. So the reason, Shane, you asked about the HSM, I want to get back to that. And at that time, these HSMs were chosen. It was the only FIPS 4 certified HSM that was available. That was the reason behind it. I'm not necessarily saying it shouldn't change, but I'm saying that was a reason. 2 key suggestion. Actually, Windows uses a similar technique in order to sign. So I'm actually supportive of that. I looked at the DPS. 5011 seems like is kind of mandatory. It doesn't say must, but it says is and may in other places. But DPS is I can update it. KSK rollover is mentioned as 5 years. One of the suggestions I have is that needs to be more frequent. I think when the planning is happening, planning should include another set of rollovers for the key right after. So we have waited, I think, 5 years. It's a long time. A lot of adoption happened. If we roll this key just 1 year after, the damage would be a lot less. So we need to do this more frequently. And the last is, there's a lot of security theater. You guys know that. Everybody has always been telling me that you guys are the experts. I think community trusts you, and I personally trust you guys. It's a big problem to solve. Keep it simple. Simple, keep it simple, and I think you'll get it done. Thanks, guys.
In the URL about changing the HSM, there are actually reasons mentioned why it stay with the current the current maker and not change to a different supplier.
Yeah, I think I just wanted to mention why it was originally chosen to use that company.
Thanks, Mehmet. Just another quick comment. I remember there was a test bed signed INR route, well, not INR route, but the test route before the deployment, well, long time before that actual DNSSEC deployment. Maybe there is something that you can do, not necessarily replicate the root zone, just like to allow people, for example, have a zone that is not really a root, just something, and then you can use that. You know what I mean? Like, it doesn't actually have to look like a real root, but it would have the same properties as during your timeline, so you can actually check the size and packet size and other things.
We already discussed that, including the 5011 aggressive roles, but there's a problem with 5011 that it takes time to roll because there are some timers, and so you cannot do it inside one day. But yes, something like this have been discussed and probably will be provided.
Yeah, thanks guys. I'll open the mic too.
Jim Reid talking for myself. I'm going to throw out another bad idea, but as I was queuing for the mic, I noticed someone's laptop saying reinstalling Windows, and there's a little winder going around, so there's obviously somebody else got some fairly bad ideas at the moment too. The point I was going to make is Oliver was suggesting the idea of trying to do something with an entity that be signed with the new key signing key, or and something within the root zone that's signed with its own signing key that's signed only with the new key signing key. And just as a possibility for that, just throwing this out there, is what about those test top-level domains that were used for all the IDN stuff? They're still in the root.
They're gone.
They're not delegated currently.
They're not delegated,
Not delegated currently.
but they could be in the root, couldn't they?
They're not in the root anymore.
They're not? Oh, well, the IANA still says they're there. The IANA list of the TLD says they're there. Okay.
I think this conversation
Told you it was a bad idea.
All right, thanks. I would like to close with one other comment too. There's one other element here that hasn't been mentioned. That's trust anchor maintenance. There's actually a draft on that. And Matt, are you one of the co-authors of that draft in the ITF? You and Joe? Yes. You and Joe. So I want to mention that draft is also being considered in the discussions of the design team, and that will be coming back to try to get some review of that in the ITF and try to progress that to an RFC document at some point. So for those of you who also follow ITF type activities, at some point we'd like to get review of that document. That document is how to also pull the trust anchors and know how to trust them outside of the automated 5011 approach. So I want to put a plug in for those drafts too before finishing. But other than that, I'd like to thank you for your participation and ideas, and some good ideas here, things that we can consider. And if you want to talk to us afterwards, we can talk a bit more about the details of this. So, but thanks.
All right, thanks everyone. With that, the official program is over, and I'll pass it over to Keith for the closing remarks.
Thanks, Liam. Okay, not really much left to say, just a few closing announcements. Thank yous to everybody who's made the workshop possible. And then you can get free beer. So, I mean, the first thing I'd like to do is just thank our sponsors, in particular, SIDN as the gold sponsor, and for the social last night. VeriSign is a gold sponsor, Comcast is a silver sponsor, Nominum is a bronze sponsor, and NZRS is a contributing sponsor. There's a whole bunch of other people that we need to thank. You know, these events are not just, they don't just happen without a load of support and help from the community. In particular, I'd like to thank all our speakers. I think it's been a great program. You know, they made considerable efforts on their own time and expenses, and we wouldn't have a workshop without them. I'd like to thank the RIPE NCC for all their logistical help with the hotel, relationship help with the hotel, and also for providing our connectivity. I'm going to, if I try and name all the volunteers, I'm going to miss people, but I think there's some particular mentions. Dave for doing all the webcast stuff and particularly dealing with our interesting remote issues. Liam for fixing up the access points so that we have wireless at short notice. Paul for making sure that all the slides are nicely queued up on the laptop. Matt for running the PGP session, and also Neil, special mention for Neil's the AV guy at the back for again dealing with all our interesting challenges. I'm glad we got there. And just thank you to everybody else who's helped in small ways and big ways. Before you return into right land, please could you return your badge holders and lanyards to the desk, the registration desk outside. Don't forget the survey. The survey is open until the 28th of May, but obviously we prefer to get your feedback while it's fresh in your mind, so please do fill in the survey. Our next meeting is in Montreal, one of my favorite cities. It's going to be back-to-back with the NANOG and Iron meetings there. The call for presentations and registrations will open on the 29th of May. Obviously, we very much welcome more presentations. We'd also like to have sponsors. If you're interested in sponsoring, we've also already had a couple of expressions of interest. And we're also interested in sponsors for our Buenos Aires meeting in a year's time. And that's pretty much it. I mean, the final thank you is just from behalf of the OARC team to thank all of you attendees. We had our second biggest workshop ever, 133, and that was a very high attendance rate as well, 440 people registered. So, that's a great commitment. So thank you all, and look forward to seeing you next time.